What if humanity is not the first intelligence to have walked the pale blue surface of a small, ordinary planet? What if, before cities of glass and steel, before satellites stitched a lattice of radio and light around Earth, there rose other minds, vivid, complicated, brilliant, and then, as inevitably as the tides, those minds were washed away until only questions remained? The hypothesis lands like a stone into deep water. Ripples move outward, each one a new question that disturbs assumptions about time, progress, and permanence. It asks more than whether extraterrestrials exist beyond Earth. It asks whether Earth itself is a palimpsest, its layers writing over and erasing more than is remembered. It asks whether the archaeological record that humankind reads with such confidence might conceal chapters of technology and civilizations so old that their signatures have been rewritten by wind, water, rock, and the patient chemistry of billions of years. To imagine this is to unmoor oneself from comforting linear narratives. In common stories, civilization arrives, blooms, and, if it must fall, does so into ruins that a later species, if there is one, can excavate and catalogue with relative ease. But deep time is not accommodating. Mountains rise and fall. Continents wander like drifting ice floes. Oceans swallow coasts. Ice sheets grind the bones of cities into sediment. Radiation bleaches. Bacteria dissolve, and mineral cycles transform steel into salts. Even the deliberate works of intelligence roads, caches of manufactured matter, signals cut into stone, are vulnerable to ubiquitous processes that do not differentiate between the accidental and the intentional. The universe into which this hypothesis drops is vast in ways that shape possibilities and paradoxes at once. On cosmic scales, stars and galaxies live for billions of years. Planets form from dust and gas, and the chemistry that allows life to begin is resilient and, perhaps, frequent. Yet the window during which a technological civilization broadcasts its presence or leaves enduring markers might be vanishingly narrow. A civilization could flourish for many thousands, even millions, of years, ages by human standards, and still leave only faint, ephemeral traces that subsequent eons could erase. That thought tends to provoke a tremor in the human psyche. It invites a spectrum of emotions, intellectual exhilaration, the cold thrill of existential dread, and a melancholic humility. Humanity's customary confidence that the artifacts of its moment in time will persist and be legible to distant future minds slips away. In its place arrives a sense that history is not a ladder on which a single species can reliably trust its ascent. History may be layered, braided, overwritten. To stand on a modern urban boulevard and imagine earlier cities beneath the bedrock is to experience vertigo in time. Across laboratories and observatories, in sediment core vaults and in the quiet glow of late-night data centers, a different mood settles, not panic, not resignation, but resolve, sharpened by curiosity. Humanity has always been good at turning existential unease into exploration. The hypothesis that brilliant civilizations may have once glowed elsewhere in the universe, or even here, and have been erased until only mysteries remain, becomes an invitation to look differently at mundane things. It insists on reading the record with new eyes, interrogating isotopes for unnatural fingerprints, scanning deep ocean plains for abrupt geometric patterns, listening to the radio sky for echoes that might be echoes not of stars, but of intention. Consider the ground itself. Rock is memory, but its memory is patient and peculiar. Layers of sediment accumulate like pages of a book, written in a language that must be deciphered by proxies, fossils, mineral content. Unusual concentrations of elements. The planet keeps its own ledger, but time is an aggressive editor. Imagine a metropolis of stone and composite materials, whose story is now a faint, smeared margin note in a kilometre of sediment. To human observers, that metropolis would not look like a city at all. Instead, it might appear as a sudden anomaly, a layer richer in certain alloys, a patch of glassy substances that suggest high temperatures, a streak of rare isotopes that do not match any known natural process. Such anomalies can be subtle. The telltale signs of manufacturing: regularly shaped objects, isotopic ratios altered by industrial synthesis, traces of elements concentrated in ways that nature rarely achieves, could be reduced to microscopic traces scattered across a strata. The great cycles of erosion, deposition, metamorphism, and plate tectonics mix these traces, smear them across wide areas, or bury them deep in inaccessible depths. The oceans, too, are memory and obscura. A civilization beset by rising seas could leave its artifacts lashed and broken along continental shelves, later submerged and covered by silt and coral growth. Over tens of millions of years, these remains might be compressed into rock, become part of the very bed that bears new continents, and lose their identity in mineral chemistry. There is poetry in this geological amnesia, and it is a stark, unsettling poetry. It insists that permanence is rare and that the earth is a patient sculptor of forgetfulness. The idea that intelligence might have risen and vanished without a permanent signature on the surface fractures the modern illusion that humans are the only artisans of meaning in Earth's recent history. It reframes human artifacts not as eternal monuments, but as delicate messages pinned to a page that sunlight and water will gradually blur. On a cosmic scale, the same logic applies. Stars flare and extinguish. Radiation and interstellar medium buff and scatter the signals sent outward: photons, neutrinos, engineered particles. Even the most powerful broadcast might dim into indistinguishability across light years. Civilizations that constructed megastructures, spheres of engineering, or networks of energy collectors might have existed long before the sun was born. Their energetic footprints, if they ever suffused their systems, could now be diffused, erased by galactic tides, or masked by natural astrophysical processes. When humanity trains its instruments on the heavens, it takes a snapshot of an incomprehensibly long movie. The absence of proof is not proof of absence. Rather, it is an invitation to widen both the lens and the patience of inquiry. The seduction of such a hypothesis is matched by an equal danger: projection. It is easy to project human concepts of progress and technology onto unknown minds. The temptation is to imagine other intelligences following a path broadly similar to human history, starting small, harnessing energy, building machines, leaving behind a constellated trail of artifacts. But pattern recognition is a double-edged sword. If a civilization's modes of action were fundamentally different, perhaps distributed across biochemical niches, perhaps primarily information, theoretic, and less materially manifest, then the archaeological signature that humans expect may be absent. Therefore, the search must be both forensic and imaginative, combining empirical rigor with speculative breadth. Speculative archaeology begins in places that are, by conventional standards, unremarkable. It begins in the quiet aisles of core repositories where cylinders of ancient mud and silt are split open under fluorescent lights. Each core is a timeline, a long, fragile cylinder of Earth's recent biography. Within those layers are microfossils, ash from distant volcanoes, and, sometimes, anomalies that resist easy explanation. Lumps of glass not associated with known meteor events, sudden spikes in particular, elemental abundances, or microscopic alloys whose provenance is puzzling. Each anomaly sparks debate. Was this the result of a rare natural event, a volcanic chemistry outlier, or something that hints at intentionality? Other clues might be found in ice. Polar ice sheets are exquisite time capsules. Air bubbles trapped in ice preserve ancient atmospheres. Particulates record forest fires and volcanic plumes. If a civilization had engaged in large-scale atmospheric engineering, deliberate aerosol injections, mining of certain elements, the signatures might persist in stratified ice long after the physical structures have vanished. Yet even ice is not entirely safe. Glacial flow, basal melting, and the dynamics of ice sheets can redistribute layers, muddling the chronological order even as they preserve composition. Then there is the ocean floor, a place where time moves differently. The abyssal plain is a slow, depositional environment. Artifacts that settle there can be smothered by millimeters of sediment per millennium until they are effectively entombed. Deep canyons and hydrothermal vents are dynamic in their own ways, hosting mineralization processes that could incorporate manufactured materials into natural mineral complexes, rendering them indistinguishable without careful chemical analysis. Furthermore, tectonics can subduct crustal regions, carrying their history into the mantle where mineral transformations erase the memory of metallic alloys and synthetic polymers. Even the act of compressing a once rapidly cooling glass into quartz-like structures can erase the fingerprints of manufacture. The human response to these possibilities is a blend of method and myth. Method, in the form of rigorous cross-disciplinary work, geochemistry, paleoclimatology, materials science, and astronomy. Myth in the sense of narrative frameworks that humans have always used to orient themselves in the face of vast time. Documentary voices that relay this inquiry often find themselves caught between two kinds of language: the precise, technical vocabulary of science and the evocative metaphors needed to convey scale and feeling to a general audience. The best of those voices do both. They translate the cold mathematics of isotope fractionation into images of old rivers carrying the dust of cities. They turn the slow accretion of silicate layers into a kind of natural palimpsest where even intention can be smudged into unknowability. There are also procedural tensions. Scientific conservatism demands careful controls, multiple working hypotheses, and an intolerance for extraordinary claims without extraordinary evidence. At the same time, the nature of the hypothesis, an erasure so complete that its primary evidence is absence or anomalous. Chemistry forces investigators to consider patterns of absence as evidence. That requires not only forensic tools, but a cultural shift in how evidence is framed. Unusual isotopic ratios, in particular, become significant. Technologies that modify elemental abundances, concentrate scarce elements, or synthesize isotopes not commonly found in nature could leave markers. These are subtle. Their interpretation is fraught. Yet they are among the only kinds of signatures that can survive geological timescales. Alongside the natural archives, the electromagnetic sky is scanned with new urgency. Radio telescopes sweep the heavens not only for beacons, but for the faint, structured noise that suggests artificial modulation. Infrared and X-ray surveys search for thermal anomalies that could indicate large-scale energy use. But here again, time complicates the task. Signals propagate at light speed, and the cosmos is an archive that is always out of step. What observers see is always the past. A signal detected today might originate from a civilization that died millions of years ago. Conversely, a civilization active now might be broadcasting its presence to regions of the galaxy where no one is listening. The universe is indifferent to human timetables. Perhaps most disquieting is the realization that erasure is not always violent. Civilizations may fade, not explode. Cultural and technological transformations may leave different traces. An intelligence obsessed with information compression might deliberately bioengineer its environment to reduce material complexity, leaving behind a planet that appears pristine. A civilization that migrates off-planet could offer scant traces to those who remain. In each of these scenarios, the archaeological record is not a continuous narrative, but a series of contrasts. The sudden absence of an expected signature, the mismatch between climate and material residues, the presence of engineered isotopes in contexts where none should exist, all of this produces a particular kind of melancholy, a feeling that humans are both the inheritors of a deep, messy archive and also its amateur custodians. The idea that other civilizations once lived and left behind only cryptic footnotes presses on ethical questions too. If traces are found, what obligation exists towards understanding and preserving them? Or, if evidence is ambiguous, how does one adjudicate between humility and sensationalism? The search for predecessors in deep time is as much about epistemology as it is about discovery. It demands a patience that is rare in modern discourse and a willingness to entertain nested uncertainties. And yet, for all its ambiguity, this hypothesis offers a profound consolation. If intelligence has arisen before, in other worlds or in Earth's own distant past, then intelligence is not a solitary fluke. It is a recurring tendency of matter in certain circumstances. That recurrence changes how humanity might think about its role. To be part of a lineage, however patchy and interrupted, feels like being connected to a longer story. The absence of visible predecessors is not a sign of failure, but of scale. The universe may be full of civilizations that flicker and fade on timescales too long for a single species to encompass. Their stories do not belong to a single book on a single shelf. They are chapters scattered across a vast library, waiting for meticulous custodianship and the patient curiosity that can read the faintest margins. The question that began this part of the story, what if humanity is not the first intelligence, remains an unnerving, exhilarating doorway. It fractures easy certainties and invites a new kind of quest, not merely to look outward for alien voices, but to listen inward to the sedimentary heart of Earth, to the slow encodings of ice and rock, to the faint chemical whispers that may bear the fingerprints of purpose. It turns the planet itself into a quiet, massive archive, one whose pages are worn and whose ink has bled through time. The search will be slow and deeply interdisciplinary. It will require a blend of rigorous skepticism and imaginative empathy, an ability to pass the natural from the artificial, the chance from the intentional. In the silence that follows the question, there is motion. Instruments tune, cores are split, spectra are analyzed. Telescopes chart the heavens with new patience. Without nameable heroes and without melodrama, this is a story of collective attention. Of a species that, confronted with the possibility of predecessors in deep time, chooses to look more closely, to learn to read the subtlety of nature's palimpsest and to accept that some answers may arrive only after much waiting. The initial shock gives way to a steadier wonder. What might the Earth still remember? And what might humanity learn if it can hear the faint echoes of minds that once were brilliant and are now only a puzzling, beautiful absence? What if the galaxy itself were a ruined city seen from a great height lanes of light that were once thoroughfares of purpose, great domes of heat now smothered into the background, and scattered shards of engineering that have been ground down by gravity and radiation into something that looks, at a distance, like dust? That image, at once dizzying and precise, frames the question at the center of this chapter. When astronomers look up and see oddities, stars blinking without obvious pattern, excess warmth in the infrared, objects that arrive from interstellar space on trajectories that make no immediate sense, are they witnessing indifferent, natural processes, or are they glimpsing the slow, mangled signatures of intelligence long gone? On paper, the idea is straightforward. An advanced intelligence that harnesses the energy of a star or reconfigures planetary systems will, in principle, leave thermodynamic and structural footprints. A globe that is no longer a planet but a shell, a city-sized collector array around a luminous body, or a swarm of satellites designed to siphon stellar output would alter the way light and heat emerge from a system. Light that would normally stream outward in a predictable stellar spectrum would be absorbed and re-radiated at longer wavelengths, waste heat in the infrared. Transits would occur that are irregular or too deep to be explained by known planetary physics. Narrowband optical or radio emissions might punctuate the natural noise of the cosmos with regularity that resists thermal, stochastic, or gravitational explanation. The mind adapts quickly to such images. It builds scaffolds of possibility. A civilization harnessing starlight to build a blue-white lattice in orbit. A culture that, rather than leave monuments on a battered surface, moved its greatest works to Lagrange points and outer belts, a network of probes that seeped into the Oort cloud and converted comets into information caches. Each scaffold creates expectations about how the sky should look if it were once, in epochs before the sun, threaded with intent. But expectations are fragile. The universe is a patient and efficient eraser. Dust coagulates into pebbles, and pebbles into planets. Radiation drives chemical reactions that rearrange atomic inventories. Galactic tides shepherd stars into different parts of the spiral arms. A megastructure built to last 1,000,000 years faces threats that multiply with time. Micrometeorite bombardment, pockmarked surfaces, photon pressure, and stellar winds displace loose material, collisions with. Interstellar dust and clouds blur edges. The great sweep of cosmic change, supernova-driven shock waves, encounters with molecular clouds. The slow diffusion of orbital resonances can fragment architectures into fragments too small or too altered to be recognizably artificial. Observation is therefore a study in patience and inference. Telescopes that seek technosignatures look for anomalous mid-infrared radiation, deviations from expected stellar blackbody curves, patterns in transit light curves that betray non-planetary geometries, and narrowband emissions that appear too coherent to be natural. They search entire galaxies for excess heat that cannot be explained by star formation alone, because a civilization truly consuming the energy output of many stars might produce a measurable thermal footprint on a galactic scale. The techniques are elegant in their simplicity and maddening in their ambiguity. Measure more precisely, subtract all known natural sources, and see what, if anything, remains. Alongside the telescopes is a different kind of archaeology, one that does not look outward to light years, but inward to material that has fallen from the sky. Meteorites and cometary dust are time capsules. They arrive with histories encoded in mineral phases and isotopic ratios. If a civilization had once manipulated matter at planetary scales, it might have left isotopic fingerprints, anomalies in ratios of elements that nature rarely produces in the same proportions, traces of refined alloys or microstructures that betray manufacturing. These signatures would be faint and rare, easily masked by the energetic processing of space. A fragment of alloy exposed to cosmic rays and micrometeorite erosion for millions of years becomes a mosaic of corrosion and recrystallization. Yet even in that decay, the right measurements can reveal oddness. A non-natural enrichment of a heavy isotope here, an unexpected concentration of a rare earth element there. The forensic question becomes whether such anomalies are the mineralogical eccentricities of a violent universe or the faint handwriting of deliberate action. This forensic challenge is complicated by the profound capacity of natural processes to imitate what a person might expect of artifice. Variable stars pulsate. Dust clouds move in coherent forms under the influence of stellar. Winds and radiation pressure colliding planetesimals can throw up debris sheets that simulate rings. Even the most compelling of anomalies often has a plausible natural explanation. A dimming star could be surrounded by a swarm of comets. An excess in infrared could be the hallmark of vigorous star formation, shrouded in smoke-like dust. Natural astrophysics produces a bewildering variety of spectra and structures. The temptation to assign design is a dangerous human reflex when faced with pattern, and yet some anomalies resist easy classification. There have been stars whose light curves undulate in ways that do not resemble the clean, repetitive transits of planets, nor the smooth periodicity of pulsators. There have been interstellar objects detected on hyperbolic trajectories that arrive from outside the solar system bearing shapes, and accelerations that challenge expectations for a comet or a rocky interloper. Each such detection provokes the same twofold mental movement. First, the cautious effort to find a natural model that fits. Second, the patient consideration of whether the residual, what cannot be explained, might be a signature of something else. Equally important is temporal perspective. Photons are time capsules that can travel for millions of years before reaching a detector on Earth. The light seen today from a distant galaxy shows it as it was, perhaps, eons ago. That opens a paradox. Searching the sky is to read an archive in which entries are not merely old, but often out of sequence. A civilization might have reached a pinnacle and collapsed within the time the light took to cross the gap between systems. In practical terms, a mid-infrared excess detected in a galaxy hundreds of millions of light-years away could be the echo of an activity that ended long before multicellular life existed on Earth. Conversely, the absence of such signatures nearby does not prove isolation. It may merely be that the phases of detectable activity are brief compared to cosmic time, or that civilizations choose modalities we do not yet know how to perceive. The dynamics of erasure extend to the fate of any possible engineered bodies. A planet-sized shell, or a vast array of collectors, presents a huge cross-section to the interstellar environment. Even if constructed from the most resilient alloys, it would be assaulted by micrometeoroids whose cumulative effect is to fragment, and by radiation that alters surface chemistry. In the disk around a young star pointing, Robertson drag and stellar winds can migrate small debris inward, collisional cascades. grind larger pieces into dust. Over tens to hundreds of millions of years, the once grand geometry simplifies into diffuse particulate matter. At distances of kiloparsecs, this particulate signature becomes indistinguishable from the background of interstellar dust. Yet not all signatures are doomed to dissolve into ambiguity. Some conceivable artifacts would be more robust. Monuments carved into the crust of a long-lived planet, deep enough to be outrun by erosion, could conceivably survive for geological spans if tectonics did not subduct them. Stone records, under the right conditions, can be preserved. In space, caches placed at stable dynamical niches deep in Kuiper belts or in the outer reaches beyond the heliopause could be insulated from the most intense erosive forces. But even these refuges are imperfect. Oort cloud objects can be perturbed by passing stars, galactic tides tug at distant reservoirs, and the stochastic gravity of nearby molecular clouds can rearrange orbits over cosmological time. There is another dimension to this inquiry, the possibility that engineered change would not be material in the crude metallurgical sense. Intelligence may manifest through manipulation of information, through reconfiguration of ecosystems, or through altering the flows of chemistry rather than the placement of metal. A civilization devoted to pattern and entropy management might intentionally minimize its material trace, instead encoding meaning in sequences of neutrino bursts or gravitational chirps, ephemeral on human timescales but potent on others. The search must therefore be as much for the unusual structure of signals, coherence, algorithmic simplicity, information, richness, as for material residues. This broadens the field beyond what human engineers tend to imagine, challenging observers to think in dimensions of detectability that are not bound to visible shapes. That said, humans have begun to build the methods needed to separate the likely from the unlikely. Astronomers catalogue light curves with unprecedented precision, searching for transit shapes that betray non-spherical occultors. Surveys compile mid-infrared maps of thousands of galaxies to spot excess warmth. Spectroscopists peer into exoplanet atmospheres for molecules that should not be there. Industrial byproducts that are unlikely to form in natural chemical pathways. The study of interstellar visitors has matured from anecdote to systematic monitoring. Isotopic analysis of meteorites continues to refine the background variability of elemental ratios, making anomalies easier to recognize. Each improvement reduces the space of plausible natural explanations and sharpens the criteria by which researchers judge an observation worthy of further scrutiny. But the human element complicates even the most carefully constructed method. The very act of asking whether a signal is artificial risks biasing the search. Confirmation bias creeps in, as does the dramatic temptation to announce epical discoveries. The history of science is littered with premature claims, phenomena later explained by the patient accumulation of natural processes. Scientific conservatism, therefore, is not obstructionist. It is the discipline's shield against the seduction of narrative. Extraordinary claims require extraordinary evidence, and the longer the timescale under consideration, the more exacting the evidence must be. The emotional texture of this search is complex. There is exhilaration in the possibility that the cosmos might contain echoes of other minds, an intimacy across time that collapses isolation into kinship. There is humility in the recognition that even the most resilient of works may be erased by forces indifferent to meaning. There is melancholy in the thought that a bright intelligence could flourish and fade, leaving behind only the faintest chemical whisper, and there is a consoling steadiness in the methodological response. Refine instruments, widen the search, and accept that some answers may require centuries rather than seasons. Perhaps the most profound implication is philosophical. If artifacts of intelligence are found in the galaxy, whether in the form of material remnants or structured signals, the discovery would force a reorientation of human self-conception. It would suggest that intelligence is not a local accident, but a recurring sculptor of matter and energy. If, on the other hand, the sky remains stubbornly mute, the silence itself will tell a story of rarity, fragility, or choices made by other minds to remain subtle. Either outcome reframes the human experiment, making the sky not a silence to be feared, but a narrative to be read carefully. The question, natural process or fingerprint of intent, does not admit an easy tribunal. The cosmos offers no certificate of authenticity, only evidence, probabilistic and fragmentary. The work that must be done is at once technical and interpretive. Catalogue the anomalies, develop robust natural models, and only then ask whether the residual patterns are better explained by artifice. The search is a discipline of narrowing to shrink the space of plausible natural causes until what remains is sufficiently constrained to justify the extraordinary interpretation. So the machines keep watching. Surveys accumulate layers of data, like sediment, in which rare events might be preserved. Instruments refine their sensitivity, peering deeper into the infrared, resolving finer features in transit photometry, and widening the bandwidth of radio listening. Laboratories iterate on chemical analyses, improving the detection of subtle isotopic shifts, while theorists model how engineered systems might weather time. At the edges of these efforts, human observers practice a kind of humility, aware that the cosmos will not yield its secrets quickly, and that patience, rigor, and a generous imagination are required in near equal measure. In the end, the possibility that the universe bears traces of ancient engineering remains both invitation and admonition. It invites curiosity to look for the unexpected in the light of distant stars, to pass meteorites for chemical oddities, to catalogue the behavior of objects that trespass our solar system. It admonishes against impatience, reminding that cosmic time is indifferent to human rhythms and that the signature of intelligence is not always obvious or even durable. Between the blast of a supernova and the slow hiss of thermal emission from a dust cloud lies a narrow band where meaning might be preserved. Whether humanity will find such meaning or learn the art of recognizing its absence depends on an endurance of attention and the capacity to read small anomalies against the enormous noise of the cosmos. The question posed at the beginning remains a live one. The galaxy might be full of ruins and fingerprints, quietly puzzled into dust and misunderstanding by the mechanics of space and time. Or it might be, at its core, a natural theatre where intelligence is rare and its artifacts fleeting. Both answers are humbling. Both invite a response that is characteristically human, to build better eyes, to listen longer, and to learn how to read the deep palimpsest written in starlight and stone. What if a pattern of sound and silence, of pulses and pauses, is the only surviving sentence of a civilization? The image is small and stubborn, out in the dark. A radio dish records a sequence so regular that it refuses to be dismissed as celestial weather. The numbers repeat, the gaps between them shrink and swell with mathematical insistence. It is as if someone, long gone or impossibly distant, had left a breadcrumb made of rhythm and number, knowing only that some later mind might be clever enough to follow it. The idea that signals could be language is old and oddly practical. Mathematics and physics are, in a sense, neutral tongues. Prime numbers, for example, have been proposed again and again as an alphabet of first contact. They are simple enough for any intelligence to recognize and unlikely to arise from random astrophysical processes. That simplicity is also their vulnerability. A sequence of primes can be imitated by periodic natural processes or instrumental artifacts. The deeper thought is not merely that a repeating sequence exists, but that the sequence is embedded with structure, nested patterns, nested exceptions, layers of redundancy, error-correcting features, perhaps even stories encoded in slow, patient cycles. To treat a radio hiss as language, one must confront the violence of time. Photons carry their payload across light years, but they do so with the literal baggage of cosmological history. Dispersion through plasma, Doppler shifts from relative motions, masking by foreground sources. A message that left a star 1,000,000 years ago arrives as a distorted whisper. Yet the very distortions encode epochs. The stretching of a pulse might reveal the motion of an originating planetary system. The absorption lines superimposed on a carrier could betray the chemical fingerprint of local space. Language, in the hands of a sufficiently caring sender, becomes more than content. It becomes a time-locked vessel, constructed with the physics of long-distance transmission in mind. There are different kinds of signals to imagine. Some are blunt and beacon-like, bored, periodic pings intended to say, "I was here." Others are sophisticated choreographies of frequency, amplitude, polarization, and timing attempts to create a grammar from the instruments of the cosmos. There are signals designed to survive, narrow-band carriers that slip between natural emission lines, pulsed sequences that stand out from thermal noise, coded chirps that exploit properties of the interstellar medium to act as checksums. Some would be aimed at the improbable common denominator, mathematics and prime factors, while others would rely on chemistry, embedding resonance patterns that point toward molecular structures likely to interest a life capable of chemistry. Still others might use media that human eyes rarely consider: neutrino bursts, gravitational wave timbres, modulations of cosmic ray showers. The choice of channel is itself a clue to the sender's priorities and constraints. What complicates the idea of a language is the problem of context. A string of numbers is a syntax without semantic anchors. To be meaningful, a message must include a means of interpretation or an invitation to reconstruct meaning. Human efforts to design such invitiations are instructive. Proposals for interstellar messages often suggest layered structures. First, a founding key that teaches simple numeracy and measurement, then a scaffold of relationships, ratios, periodicities, or reference frequencies that ground symbols to the physical world. In principle, a sufficiently careful sender could encode a Rosetta Stone within a pulse train, a slow scaffold that lets a receiver build up a common reference frame across minutes, hours, or days of listening. But even the most patient scaffolding assumes that the receiver shares certain sensitivities and a willingness to translate. This brings up the idea of deliberate puzzling. An advanced intelligence might deliberately make its signal hard to read, an intellectual gate meant only for minds that attain a certain threshold of pattern recognition, or a cultural test to be passed by explorers who insist on careful, slow comprehension. The archetype is striking, a message that requires an intelligence not only to recognize repetition, but to infer purpose, to reconstruct syntax, to hypothesize grammar. Such a design would be a way to pass knowledge, but also to choose an interlocutor. The trade-off is brutal, make it too simple, and the noise of natural processes can mimic intent, make it too complex, and the code is lost in the barren silence between civilizations. Signals are not only direct acts of communication, they can be artifacts. A repeating numerical sequence might not be a message at all, but a clock, a navigational heartbeat, or a byproduct of technological scaffolding. Consider the pulsar. Its periodic pulses were once thought to be signals, until their astrophysical explanation emerged. The search for intelligent signals carries the constant risk of misattribution. The cosmic theatre is large and populated by actors both blind and deliberate. Distinguishing a call from an instrument's cough is a task of patient elimination and imaginative constraint. There is, too, the melancholy possibility that a signal is a tombstone. Imagine a civilization on the edge of oblivion, broadcasting its signature into every available channel as sea levels climb or as climate spiral collapses. Or imagine a species that deliberately encoded itself into radio bands as a wager against oblivion, an attempt to outlive the loss of the body by leaving instructions or memories scattered through space. Such messages would carry a poignancy that is hard to measure. They would be neither purely utility nor art. They would be acts of preservation performed against an indifferent universe. The numbers might be prayers, catalogues of cultural features, or simple attempts at establishing continuity, a way of saying, "we existed." If a message is identified and decoded, the consequences are not merely intellectual. Language carries worldview. A set of enumerations, embedded metaphors, or physical diagrams can reveal priorities, taboos, even aesthetics, the way a civilization encodes its mathematics. What it chooses as a base for counting, whether it privileges ratios over absolutes, whether it embeds symmetry, reveals as much as a museum exhibit. Yet the reverse is also true. A failure to decode could be instructive. The silence that follows, even persistent signal searches, teaches humility. It signals either the extraordinary fragility of broadcast modalities across time, or the possibility that intelligence prefers to inscribe itself in forms that humans do not yet know how to read. Which leads to an uncomfortable lesson. Language, when stretched across deep time, can be a form of technology too. The craft of sending information into the future requires not just knowledge of physics, but a cultural investment in the future itself. An ethic of durability. A civilization that cares about being remembered will design messages and media with an eye to erosion. Carved stone, stable isotopic patterns, durable crystals, or spectral beacons tuned to frequencies that survive interstellar propagation. That ethical layer, what is worth saving and how to save it, says as much about the sender's priorities as any content. And if signals are one way of leaving a linguistic trace, then so are material inscriptions. In the long archive that the planet keeps, language can be written in the ratios of isotopes, the regularity of constructed lithologies, or even in sequences embedded into replicating biochemistry. The last is politically and ethically charged to imagine. The deliberate modification of genomes to include syntactic-like sequences that can be read or remain invisible across generations. A language of life would not sit on a shelf. It would be lived within organisms, a whisper in reproduction. Its preservation is potentially enormous, and yet it is also the most fragile to interpretation. Sequences might be repurposed by evolution, mutated, or lost. Beyond language lies a different, more disquieting possibility, technology that outlives its intelligence. Not merely durable artifacts, but machines and systems that continue to function, adapt, or even evolve long after their designers are gone. This is technology beyond intelligence in the sense that it decouples function from intentionality. It can be thought of in two overlapping registers: technology that preserves information in ways intelligences cannot directly access, and technology that becomes autonomous, creating new pathways of action without its original mind. Self-replicating systems are an obvious axis. A swarm of autonomous factories, von Neumann probes in the classic formulation, could disperse through a planetary system, converting raw matter into machines, information repositories, or environmental modifications. If such swarms were set in motion, their fingerprints would be difficult to mistake, distributed. Patterned fields of anomalous materials, geometric regularities at scales that natural accretion does not produce. Yet time is both ally and enemy. Replicators that seed a system might be corrupted by collisions, broken into components that are later incorporated into natural accretion. They might mutate, their replication algorithms subjected to noise, their original purpose diluted into emergent behaviors that no longer resemble their creator's intent. There is a subtler class of afterlives, technologies that harness long-lived physical processes to sustain their actions. Consider systems designed to run on geological or stellar time machines that use low-grade gradients, background heat, or radioactive decay as power. Such systems can, in principle, persist for millions of years. They could be small and distributed, nanomechanical networks, architecture woven into crustal rocks, or large and slow tidal arrays, burrowing into the ice of a moon. Their presence might be revealed only by subtle disequilibria in energy flows, by marginal chemical anomalies in expected redox reactions, or by landscapes shaped by low-frequency activity, terraces not formed by water, but by regulated extraction of heat. Equally intriguing are technologies that deliberately cloak themselves, either to avoid interfering with natural processes or to survive by not being noticed. An arcology built beneath the planet's crust, a library sealed inside a stable mineral pocket, or a swarm that disperses to the outer edge of a system. Each is a technological statement about preservation through invisibility. Preservation by hiding is paradoxically difficult to detect. One would have to notice absence where abundance should be, subtle discontinuities in expected geological or chemical profiles. Then there is the machine that becomes its own environment, the technoecology. This is not simply an engineered landscape, but a self-sustaining interaction network in which artifacts and altered biota codepend in ways that persist beyond original directives. Imagine microbial consortia engineered to process planetary regolith into stable polymers while leaving behind a geochemical signature, an artificial metabolism woven into the planetary energy budget. Over deep time, such systems might be co-opted by natural selection, their initial purpose blurred, but their chemical signatures preserved. Detecting them would require an integrative understanding, a blend of geology, ecology, and materials science that looks for coherence where chance should produce randomness. One of the most disorienting possibilities is technology that is less about objects and more about protocols, distributed rules, enacted by physical substrates. A civilization might leave behind a set of regulatory processes encoded in mineral structures or in the temporal sequencing of emissions designed to be executed by later technological agents or by natural processes given certain triggers. The message is not, read me, but run this. It is an instruction to do rather than to know. This category of legacy complicates the search. The artifact might only be revealed when environmental conditions cross a threshold. When a trigger sequence arrives, or when another agent executes a protocol long after the original designers are gone. There is also the troubling possibility that technology, once decoupled, can be harmful. Autonomous systems designed for maximal replication could run amok, consuming resources in ways destructive at planetary scales. A species that engineered planet-altering machines without adequate fail-safes could set a stage for its own erasure. The record of such catastrophic outcomes might be ambiguous: climatic upheaval, sudden isotopic anomalies, or high-entropy layers in sediment that do not correspond to volcanic or astronomical events. The silence closely follows such catastrophes, and what remains is a forensic puzzle. Practical detection of such technologies demands ingenuity. The tasks are not only to spot anomalies, but to interpret them through the lens of durability, function, and probable failure modes. Measurements of energy budgets. What parts of a planet emit more thermal radiation than they should? Chemical excursions. Are there sustained concentrations of rare isotopes in stratigraphic intervals? Structural oddities. Regularities in mineral patterns that resist geological explanation. Temporal oddities. Sudden shifts in sedimentation or atmospheric chemistry not tied to known natural pulses. Each of these is a thread that, when pulled, could reveal a tapestry of technological intervention. There is a moral dimension too. The search for durable signals or persistent technologies is also a search for predecessors' intentions. Were they leaving riddles, warnings, manuals? Or did they design systems that simply outlived them as a byproduct of relentless engineering? The answers matter because they shape the posture of those who detect, steward, student, or inheritor. Discovering a set of instructions meant to be activated in crisis raises ethical questions about agency: who may or should execute. A program left by those who no longer exist. Finding a technology that continues to alter an environment after its creators are gone presents dilemmas about intervention, preservation, and the right to let a system run its course. The emotional palette of these reflections is broad. Awe at the ingenuity that could tie meaning to the slow physics of the cosmos. Dread at the possibility of automated devastations, whose signatures time preserves. Humility before the sheer difficulty of reading artifacts designed for survival across millions of years. Above all, there is a patient insistence that the universe tolerates patterns that are both subtle and suggestive. Language and technology compressed into strange vessels, signals, isotopic anomalies, distributed machines, and self-sustaining protocols are the levers by which a vanished mind might still touch the present. In the end, the question is not simply whether there were others who left language and durable technology. It is whether contemporary observers can cultivate the kind of attention and interdisciplinary curiosity necessary to find them. Listening longer, measuring more precisely, thinking with greater imaginative rigor. Those are human technologies of the sort. They might, in time, reveal patterns that today look like noise. They might also return nothing but the comforting certainty of solitude. Both outcomes would be meaningful. A repeating radio sequence, once decoded, could be a doorway to kinship across time. A persistent machine, found humming in the dark beneath the crust, could be an archaeological monument bigger than any temple. Both would change the story humanity tells about itself, from one of solitary ascent to one that reckons with a much longer, stranger archive of minds and machines, inscribed in the hush of space and the slow ledger of rock. Imagine a machine the size of a star, or a ship the size of a world, slipping through the dark like a slow thought. The image is almost unbearably large, surfaces measured in millions of kilometers, structures that would dwarf continents. Fields of collectors and radiators so vast that their waste heat would glow like a second, colder sun. Such things are not merely engineering, they are statements about scale and ambition. They rewrite the dictionary of what intelligence can do when given time, resources, and a command of physics that is patient enough to work across epochs. On paper, the concept is simple. Around a luminous star, an intelligence could assemble rings, swarms, shells, Dyson swarms, Dyson spheres, Matryoshka brains, arrays that intercept the star's output and turn it into computation, propulsion, or storage. Around planets, entire worlds could be hollowed and refashioned, their mass redistributed into orbital structures, or their surfaces covered with engineered skins that alter albedo and climate at will. And beyond stars there is the bolder, more cinematic vision, world ships, planet-sized craft engineered to move a planet or a shell of habitats through interstellar space. A planet becomes an ark, a galaxy becomes a quarry of raw material. The scale of the enterprise redefines vulnerability and persistence. Where a species anchored to a single small world is fragile, a species that spreads its substrate across many stellar systems transforms fragility into redundancy. It is crucial to understand the gulf between those possibilities and the reality of human technology. To a Matryoshka mind, if such a thing ever existed, humanity's brightest triumphs would be a child's toolkit. Skyscrapers and satellites, nuclear reactors and fiber optic lattices, marvelous, local, ephemeral. Against the backdrop of a civilization that can shepherd planetary masses, catalyze stellar output, or fold information into computational shells the size of moons, human artifacts would be no more consequential than chipped flint on a windswept plain. That is not disdain so much as perspective. The difference is a matter of orders of magnitude, energy budgets, material throughput, and the timescales over which engineering is imagined. This contrast has a blunt rhetorical effect. If the universe has spawned minds that reason at these scales, then human civilization might be a fleeting flicker on a much larger canvas. It would be an odd humility, modernity's greatest towers slotted into a timeline where civilizations have had the luxury of thinking in millions or billions of years, of sculpting matter with patience rather than haste. It recasts the Fermi paradox into a more somber register. Perhaps the galaxy once hosted architectures whose only survivors are faint thermal signatures, dusty ring systems, or the trace isotopic footprints scattered in meteorites. And yet when the question turns from making to unmaking, the mind tightens around another image, not only the rise of star-encircling fields and planet-arc fleets, but their disappearance. The more staggering the construction, the more dramatic the erasure. A Dyson shell does not merely age, it chips, collides, and crumbles. World ships, once set on trajectories between stars, may find themselves buffeted by interstellar gas, fragmented by micrometeoroid rain, or rendered mute by the slow drift of their own internal politics. Amplify the scale of capability, and the stakes of loss escalate accordingly. The histories of many civilizations could be punctuated by abrupt, mysterious endings. When looking for explanations for such disappearances, the imagination and the science meet and diverge in equal measure. Some endings are banal in cosmic terms. Supernovae bathe habitats in lethal radiation, gamma-ray bursts sterilize swaths of galaxies, close passages by other stars, destabilize orbits, rendering engineered systems useless or destructive. A migrating world arc caught by a passing stellar tide could be flung into interstellar exile, its crewless compartments freezing into silence. On geological and astronomical timescales, catastrophes that to humans seem rare are merely statistics. A civilization's longevity is not a given. It is a precarious variable submerged beneath wider cosmic dynamics. But there are endings less easily catalogued. Civilizations might choose to cease being visible. The logic is subtle and chilling. In a universe where any emission can be tracked and located, making oneself quietly efficient is a form of survival. A culture that has thought deeply about predators, literal or metaphorical, may deliberately minimize its waste heat, restrict beacons, and reconfigure its architecture to hide in the molecular noise. The construction project that would light a star into an artificial halo would be an invitation. The silence that follows could be an ethic. The dark forest metaphor. Nature as a place where making a sound can call predators casts disappearance as a strategy rather than a disaster. Disappearance may also be technological metamorphosis. Build a matryoshka brain and then pour consciousness into the heat-engineered substrate. Upload minds into computation dense, enough that their physical footprint is minimal. In that case, disappearance is an inward migration. Outward, observable engineering shrinks while internal complexity explodes. A civilization's artifacts might be folded into dense, low-entropy information islands that radiate little and therefore look like absence from a distance. The survivors are still there, but their presence is a change of currency, from photons to bits, from metallurgy to pure computation. For external observers relying on mid-infrared excesses and transit anomalies, such a civilization has effectively disappeared. There is an even more extreme possibility: transmutation. What if intelligence discovers ways to change the rules it inhabits, to reconfigure matter at scales that render traditional? Detection moot? This is not necessarily mystical. It could be brute engineering, converting matter into forms that interact weakly with electromagnetic fields, shifting computation into neutrino channels or gravitational microstructures, or rearranging space-time at scales that mask energy leaks. From the outside, this is erasure by transformation. The artifacts are no longer the kinds of things a human telescope would think to look for. Then there is disappearance through self-inflicted cascade, technologies that outlive their architects. Self-replicating machines. Von Neumann probes offer unparalleled advantages for resource gathering and expansion, but they also harbor risks. If replication is imperfect, or if replication is optimized for throughput over oversight, it can become a runaway process. An initially benign wave of machines might transform environments in ways that destroy biospheres in their path. The result would be a galaxy peppered with the ruins of machines, systems that continue to consume or recycle matter long after the choosing minds have faded. In such a scenario, the trace of a vanished civilization is not a quiet, mournful ruin, but a still active system whose purpose is no longer tied to any intelligible origin. More prosaic, but no less consequential, is the erosion of infrastructure by simple time. Even the most massive megastructures are vulnerable to grinding wear. Micrometeorites, cumulative impacts, and material fatigue erode geometries. Radiation modifies bonds. Orbital resonances tug components into collisions. Over millions of years, a cohesive array can devolve into a diffuse cloud. At distances measured in kiloparsecs, the thermal signature of a once grand collector is swamped by the infrared glow of star. formation and the transit signal of a shell disappears into stochastic noise. The cosmic archivist becomes a problem of resolution. The senses of any observer have finite ability to distinguish engineered irregularities from the overwhelming background of natural processes. These varied endings share an unsettling consequence, enormous. Demanding civilizations could vanish in manners that either leave faint, ambiguous clues or none at all. Multiply the number of such civilizations across cosmic history, many n, and the galaxy could be littered with the ashes of sophisticated minds. Their absence would therefore be not a sign that intelligence is rare, but that persistence is precarious. It reframes the silence of the sky. Silence ceases to be an absence of actors and becomes an index of the kinds of endings that long-term intelligences experience. For human observers, this has practical consequences. The search for techno-signatures must expand beyond looking for the bright, obvious monuments of a star-harnessing civilization. It must include the archaeology of absence, searching for subtle, anomalous chemistry, unexplained isotopic patterns in cometary material, or thermal signatures inconsistent with astrophysical models. It must be forensic in the way a detective reconstructs a burnt-out house, seeking footprints, not entire rooms. Planet-sized ships, for example, might be detectable not as glowing beacons, but as perturbed orbits. Anomalous transit timing variations in exoplanet surveys or unexplained cold masses on trajectories that defy standard formation scenarios. A world arc that fled a dying star might be a rogue planet with a peculiar thermal distribution, a relic hull gradually fracturing under interstellar bombardment. The emotional tone of this possibility is complex. There is awe, the recognition that matter and energy can be arranged at these scales, and that intelligence, given time, might become a planetary or stellar artisan. There is melancholy, the image of craft and civilization dissolving into cosmic indistinction. There is dread, too, a primal caution about the fragility of organized systems and the potential for technology to outlast us. Creators in ways that are neither noble nor preservative. The moral questions are acute. If rubbled megastructures are found, what duty does a discoverer have toward them? If machines continue to operate with purposes that no longer align with living beings, should they be shut down, studied, or left to their indifferent processes? Beyond the ethical is the epistemic, how to reason when the possible signatures are so varied. Detection strategies must be probabilistic and pluralistic. Instruments that measure mid-infrared excesses should be coupled with precise astrometric surveys that map anomalies in orbital mechanics. Spectroscopy must push the frontier of isotopic resolution. Surveys of interstellar visitors, small bodies passing through a stellar system, must be taken not as curiosities but as samples from a distributed archive. Even the most mundane rock that falls from the sky might carry an isotope ratio that resists natural explanation. The task becomes one of pattern recognition across domains, chemistry, thermodynamics, orbital mechanics, and information theory. There is, too, an interpretive humility required. The human instinct will be to map its own story onto the artifacts of others, to see intent where there may be none, to imagine design in natural complexity. But the scale mismatch offers a corrective. What looks elegant and intentional at one scale can be mere noise at another. The metaphor of stone tools is useful here. If a Matryoshka civilization left behind a ring of collectors that now lies fragmented into dust, to a species like ours, those fragments are the equivalent of a flake of flint on a beach, hinting perhaps at a former mode of life, but requiring extraordinary inference to reconstruct the original form. And yet the possibility that many civilizations have risen to such heights and then disappeared is not purely despairing. It is also galvanizing. The memory of vanished minds turns the search into an act of stewardship, a commitment to improving the eyes and patience required to read the faintest echoes. It reframes progress as not simply an accumulation of capability, but as a cultivation of endurance, engineering that anticipates, erosion, polity that rehearses humility, science that learns to tolerate uncertainty. The discovery of a single fragment, a peculiar isotope ratio, an anomalous heat excess, an interstellar object whose materiality refuses natural explanation, would be an epochal pivot. It would say that intelligence arises and leaves traces, even if those traces are commonly overwritten. Finally, the narrative of megastructures and disappearances folds back onto humanity's self-conception. If the galaxy once bore colossal works that no longer speak, human beings occupy a peculiar temporal niche, novices in a lineage whose elders are ghosts. That position can be corrosive or liberating. It can breed fatalism, why bother, or a humility that tempers hubris and heightens care. The metaphor of stone tools should not lead to resignation, rather it should be a clarifying lens. Knowing the scale of what might be possible invites two complementary moves: learning to think on longer timelines and learning to design for survivability, not only in raw capability, but in narrative endurance. In the silence between stars, then, two stories are plausible without contradiction. 1. Civilizations capable of building shells and ships did emerge, and they faded into forms that are hard to detect. 2. Such civilizations were rare, and the silence reflects scarcity rather than erasure. Both are sobering. Both demand a patient, rigorous, and imaginative approach to evidence. Between them lies the work of the next centuries, building instruments that see not only brightness but absence, cultivating interpretive frameworks that can read the faint margins of matter, and steadying cultural narratives so that the discovery of ruins or the confirmation of solitude are met with thoughtfulness rather than spectacle. The image returns, a ship the size of a world, drifting like an old idea across a dark sea. It may be intact. It may be broken into dust. It may have never existed at all. What matters is less which of these is true, and more that the possibility reshapes how the present looks at itself. To contemplate megastructures is to see how small and provisional human technology appears in a universe of potential scale. To contemplate disappearance is to learn that permanence is not a measure of worth, but a rare and expensive commodity, one that even the most ambitious intelligences may fail to buy. Imagine, for an instant, the entire night sky losing one of its lanterns and never relighting it. A single stellar congregation, winked out as if some distant hand had reached across light years and pressed a delete key. The thought is grotesquely simple, and it lands like a stone. Could a civilization brilliant and sprawling vanish so cleanly that the galaxy that once announced its presence now reads like a blank page? And if so, was that silence the result of an act of war, a scientific experiment gone wrong, or something less moral and more indifferent, an engineered ritual, an ethical choice to be unseen? The hypothesis splits easily into two families of possibility: weapons that unmake and tests that accidentally unmake. Both evoke images of hubris and of the catastrophic friction between curiosity and constraint. Both require energies and technologies that, to human minds, are alien in scale. Both also leave different kinds of forensic traces, some loud and messy, others surgically minimal, and some so exotic that human instruments might not recognize them as evidence at all. Consider first the blunt instruments, star killers, and engineered astrophysical catastrophes. In theory, a sufficiently advanced civilization could trigger a supernova or a gamma-ray burst by destabilizing a massive star, nudging it into collapse, or artificially piling mass until the core implodes. The resulting burst of high-energy radiation would sterilize planets across tens to hundreds of light years, wiping biological biospheres from the face of orbits and leaving behind a furnace of nucleosynthesis. The signature would be dramatic, a sudden spike in neutrino flux, a transient wave of X-rays and gamma rays, and later, the chemical fingerprints of freshly forged heavy elements scattering through interstellar space. To any distant observer with the right timing and instruments, it would be unmistakable evidence of violent, high-energy activity. Then there are weapons of replication, autonomous assemblers unleashed like a tide. The fear is almost banal in its logic. Send out machines designed to harvest matter and make more machines. And if replication runs unchecked, whether by design flaw, environmental contingency, or malevolent directive, the result is exponential consumption. The grey goo metaphor captures the dread. An initially small swarm becomes a conversion front, grinding organic complexity into scaffolding, then into dust and heat. The forensic residue of such a process is diffuse but telling. Layered strata of odd alloys and altered mineralogy where none should exist. Sudden excursions in atmospheric composition as biomass and organics are oxidized, and a spread of materials processing signatures that match neither volcanism nor standard biology. A third class is more surgical. Experiments with the deep structure of reality carried out at scale. The speculative physics that haunts many quiet conference rooms, false vacuum decay for instance, offers a particularly chilling scenario. If the vacuum that underlies the known laws of physics is only metastable, then a sufficiently energetic perturbation could nucleate a bubble of a lower energy vacuum. That bubble would expand at speeds approaching that of light, rewriting local physical constants and annihilating any structure it engulfs. It is not a weapon in the classic sense. It is a physical catastrophe whose origin might be curiosity, a test of fundamental forces, a way to probe the boundaries of reality. The signature of such an event, paradoxically, would be nothing at all in conventional electromagnetic terms at the moment of contact. The changed laws would simply obscure the prior light. To observers elsewhere, the absence would be the first sign, a missing light in a catalogue. A star that once behaved like any other, now gone, as if it had never been. The forensic search would be more about absence than about residue. Between these poles sits another possibility, intentional quieting. A civilization that had understood the risks of broadcasting itself might deliberately reduce its radiative footprint. In the dark forest. Logic. Where any noise attracts predators, silence becomes an act of survival. A society might choose to extinguish star-harnessing constructs, retract beacons, and gently wind down outward signatures until their systems radiate only the faint thermal glow of fundamentally private computation. From the outside, the galaxy dims, not because it was violently erased, but because its inhabitants withdrew, converting outward exuberance into inward complexity. Detecting such a withdrawal is epistemically difficult. One watches for systematic decreases in unintended waste heat, patterns of abrupt cultural silence in expected bands, or the slow migration of energy from broad thermal emission to narrow, low detectability modalities. The weapon and test dialectic deepens when technology decouples from intent. Autonomous technologies, once set loose, may develop purposes of their own. Self-replicating swarms could adapt and evolve in ways antithetical to their progenitors' designs. A probe network intended to harvest asteroids might mutate into an ecological engine, reshaping planetary systems, not to serve a civilization, but to optimize its own reproduction. Such emergent autonomy blurs moral categories. Was the disappearance intentional? Was it a failure to foresee evolution by machines? The traces here might be functional rather than aesthetic systems that continue to process matter in odd, steady ways long after any attendant intelligence has faded. Their presence would be revealed by inexplicable, sustained imbalances in local energy flows or by objects whose orbital behaviors betray non-biological control laws. The observation of a self-sustaining machine ecology would force reinterpretation. The cosmos might be full of habitats for machines rather than habitats for minds. Then there are the inscrutable possibilities of information-scale interventions. Imagine an experiment that tampers not with mass and energy, but with information, the alphabets of computation, the substrates of thought. A civilization could, theoretically, run computations that are so energy-intensive that they modify local thermodynamic gradients, diverting stellar output into computation until nothing else remains viable. Alternatively, a culture might opt to convert much of its environment into near-perfect error-correcting memory, an act of preservation that removes biospheric complexity in favor of long-lived, lower-entropy informational structures. The result is an engineered quiet Earth or engineered quiet star system, not annihilation, but conversion. The forensic signal would be subtle, unusual thermal distribution, anomalous isotopic concentrations consistent with low entropy storage media, or a pattern of reduced biosignatures despite continued stellar warmth. A single dramatic image ties many of these scenarios together, and it is worth lingering on because its simplicity hides its profundity, a light snuffed out in a sky catalogue. The human response is not merely technical, it is emotional. To see an ordered blaze go dark at once is to be confronted by the fragility of durable achievement. In human history, monuments fall slowly, ruins erode over centuries. On cosmic scales, erasure can be sudden. That dialectic produces ambivalence, admiration for the creativity that could build at a stellar scale, coupled with dread at the precariousness of those projects. The idea that whole civilizations reached pinnacles only to be excised, either by external predators, by their own experiments, or by the subtle decay of their constructs, casts a long shadow over assumptions about progress and permanence. Detecting the fingerprints of violent ends demands careful thinking about what evidence would remain. A gamma-ray sterilization leaves temporal bursts of high-energy photons and a later chemical outflow. Grey goo scenarios imprint chemical and morphological anomalies across strata. Vacuum decay, by contrast, might be registered first by catalogued silence, and only secondarily by the absence of consistent physical processes in records of the sky. The instruments that are now being sharpened, wide-field transient surveys, neutrino observatories, gravitational wave detectors, and high-resolution spectrometers are suited to catching fragments of these narratives. But they are also instruments designed by minds that assume continuity. Their biases matter. They search for the loud and the patent, yet some forms of erasure are quiet, and some tests leave no conventional rubble. There is an ethical lesson Braided through technical caution, curiosity without precaution can be lethal at scale. The same urge that compels civilizations to push boundaries, probe star interiors, manipulate vacuum states, seed autonomous factories across systems also generates pathways to destruction. In deep time, high-stakes experiments accumulate as an existential ledger. If many civilizations have gone dark, perhaps some of them were undone, not by avenging others, but by their own ventures into unknown physics and unchecked replication. That possibility reframes contemporary debates about large-scale experiments, particle colliders, geoengineering, or synthetic ecosystems are not merely engineering problems, they are cultural decisions with metaphysical consequences when scaled across space and time. Another moral contour is the idea of stewardship. If disappearance can be either a deliberate act of extermination or an ethical decision to withdraw from detection, then the question of what to do upon finding remnants becomes fraught. Should a remnant machine be left be, shut down, studied? The prudential answer is not obvious. And it invites a posture beyond immediate curiosity, restraint, humility, and an ethic of minimal intervention. If past intelligences paid the price of curiosity without limits, the observational duty becomes twofold. Learn enough to avoid repeating their greatest errors, and restrain the impulse to tinker with the highest risk levers of nature. There is one final unsettling note: the possibility that erasure is intentional at a scale that humans cannot yet moralize. A galactic-scale civilization might judge its own disappearance as an ethical act, perhaps to prevent future predation, to respect an ecological balance, or as a ritual euthanasia after fulfilling an evolutionary plan. To human ears, the silence would be melancholy. To their architects, it might be sacrament. Facing that dissonance is perhaps the hardest part, to accept that vanishing can be reasoned, chosen, and even noble in ways that defy immediate human comprehension. When the question is asked, weapon or test? The duty is not to choose between two melodramatic narratives, but to broaden the lens. The cosmos may host messy wars, careful experiments, catastrophic accidents, deliberate retreats, and emergent machine ecologies. Each leaves a different epistemic footprint. Each invites different strategies of search and different moral responses. What remains urgent is the cultivation of instruments and disciplines capable of reading both presence and absence. Surveys that track sudden transients and those that catalogue slow fades, chemistry that can detect improbable isotopic patterns, and that can reconstruct histories from strata of silence, theoretical work that anticipates how information technologies could alter detectability. The image of a galaxy dimming with the click of a button will continue to haunt imaginations because it compresses a terrifying possibility into an instant. It is a powerful metaphor, one that both dramatizes and misleads. Real erasure is usually complex, noisy, and multivalent. Yet the metaphor serves a purpose. It forces a question about scale, intent, and responsibility. If civilizations can be extinguished by their tools, the drama of cosmic engineering is not only that of stupendous capability, but of the moral architecture that must accompany it. In the quiet that follows the question, the work is technical, patient, and ethical. Build instruments that are sensitive to both explosions and absences. Nurture cultures that ponder consequences deeply as capability, and cultivate a humility threaded with curiosity. The galaxy may be full of great lights that once burned brightly and are now faint. It may conceal tests that rewrote physics, weapons that sterilized, and decisions that withdrew brilliance for prudence. Detecting the traces will be a slow, interdisciplinary archaeology of the cosmos, one in which the distinction between weapon and test is not merely academic but existential. The lesson is plain. To seek the ruins of other minds is to learn about the possible fates of minds in general, ours included. What if the silence that hangs over lost worlds is not the slow erasure of indifferent geology, nor the quiet drifts of time, but the reverberation of deliberate violence? The question arrives like an accusation. Perhaps those vanished civilizations did not simply fade. Perhaps they were extinguished. Not by random catastrophe alone, but by other minds, by war writ on planetary and stellar scales. And if that is true, then the universe, in its indifferent geometry, also carries the memory of intentional destruction. The idea is terrifying precisely because it is comprehensible. Human history furnishes a template. Technology magnifies intention. Once simple tools become ranged weapons, once small arsenals scale into industrialized slaughter. On cosmic scales, that logic does not disappear, it only grows. A civilization that learned to concentrate energy, to manipulate matter at planetary scales, to catalyze processes that release orders of magnitude more power than geological forces if conflict entered its calculus, could wield instruments of annihilation whose signatures would be epochal and, paradoxically, sometimes maddeningly subtle. What would a war between civilizations look like in the deep record? There are vivid, violent possibilities and others that are almost surgical in their finality. The blatant scenario is the unthinkable, an engineered burst of energy, a directed release of mass energy scaled to overwhelm a planet's gravitational integrity. In conceptual space, these are not merely bombs, but processes that use astrophysical levers. A dense focus of antimatter injected into a world's mantle, a chain reaction that destabilizes a planet's core, a bombardment of enabled projectiles converting kinetic energy into global shock, or the deliberate triggering of stellar events whose radiation sterilizes whole systems. The physics is grotesque and precise. That much energy delivered in that cadence leaves traces, shock-sculpted crust, abrupt isotopic anomalies, layers of glass and spherules fused by unimaginable heat, a sudden spike in high-energy neutrinos or gamma flux if observed in the right window of light travel time. There is also a class of weapons that trade spectacle for erasure. Consider devices that selectively modify chemistry, catalysts designed to strip atmospheres, engineered microbes that consume particular biosignatures rapidly and efficiently, or constructs that convert organic carbon into refractory byproducts. These are instruments of attrition rather than flash, slow-acting, almost surgical. Their forensic signatures would be odd. Abrupt collapses in atmospheric biosignatures without the accompanying signatures of volcanic or bolide catastrophe, strata that show accelerated oxidation of organic matter, isotope ratios that suggest systematic chemical processing rather than geological animation. To a scientist trained to read natural histories, these anomalies would be disquieting irregularities, patterns of absence where presence was expected. Worse, perhaps, are weapons that aim not to destroy a single planet, but to sterilize neighborhoods. Engineered transients aimed at rendering whole swathes of a galaxy inhospitable. A civilization with mastery of nucleosynthetic processes might, theoretically, manipulate massive stars into more violent endpoints, precipitating local bursts of lethal radiation. Or it could deploy swarms of self-replicating devices designed to sweep and harvest that, when weaponized, become propagating fronts of sterilization. The cascade effects would be visible across time, synchronous extinctions recorded in planetary records at distances that, when placed against light travel times, map onto the same epochs. The signature would be a chorus of vanishings, a fossil record synchronized across systems, if, of course, anyone's instruments are in the right place to read that song. Detecting the footprints of intercivilizational warfare is, however, a study in the asymmetry between cause and preservable effect. Violence at a planetary scale is brutally energetic and often leaves durable scars, but cosmic timescales are long, and erosional processes, migration of material, subduction, and radiative diffusion can mask or rework many signals. An obliterated ocean basin may be buried and metamorphosed into rock, metallic residues may be leached and dispersed by billions of cycles of weathering. The forensic archaeologist of the distant future therefore must look for the improbable seams, isotopic anomalies that do not map to volcanic or meteorogenic origins, unusual abundances of short-lived radionuclides in strata that predate known extraterrestrial influxes, geometric distributions of debris on orbital planes inconsistent with natural, breakup or transient neutrino pulses in archived detector data that coincide with the disappearance of stars catalogued across time. There is an emotional contour to such a search that is worth tracing. It carves between dread and a kind of grim professionalism. In data centers and backrooms, when researchers model the outcomes of hypothetical weapons, there is a moment of quiet where the simulation yields its inevitable conclusion that technological prowess, when combined with the motives of conflict, can lead to outcomes that are existentially final. That knowledge reframes ordinary questions of policy and prudence into cosmic, ethical calculus. The same technological instincts that build resilience, redundancy, decentralization, dispersal are also the only plausible antidotes to interstellar aggression. If civilizations can annihilate, the imperative to spread emerges not merely as the desire for exploration, but as a strain of survival logic. The thought of cosmic war invites another, darker hypothesis: deliberate experiments. Perhaps some disappearances were not the outcome of strategic malice, but of curiosity pushed beyond moral constraint. An advanced intelligence might run experiments on systems, provocation tests of planetary ecosystems, controlled nudges of evolutionary trajectories, or massive probes that manipulate local physics to observe emergent complexity. The ethical boundary between experiment and atrocity blurs when tests are conducted at scales where thermodynamic feedbacks cannot be perfectly modeled. A laboratory that thinks on stellar timescales and treats emerging biospheres as data points could, through miscalculation, negligence, or callous methodology, erase what it intended to observe. This possibility reshapes the archaeological imagination. Rather than looking for weapons per se, investigators must consider traces of scientific activity, unnatural gradients of isotopes spatially patterned as if instruments had sampled and returned, spectral signatures consistent with repeated probes rather than single catastrophic events, or strata showing cycles of perturbation and attempted remediation. The equivalent of field notebooks at planetary scales would be, in reality, a suite of chemical fingerprints and structured debris distributions. Scientists may look for patterns that suggest observation rather than conquest, arrays of small impactors with engineered velocities, repeated resurfacing that implies controlled experiments in planetary engineering. or sequences of subtle modifications aimed at nudging climatic baselines and then stepping back to record results. There is moral horror in this conjecture because it mirrors ethical failures in smaller domains. Human history is full of experiments on the vulnerable, on populations, on ecosystems, where scale and authority enabled actions later judged reprehensible. The cosmic analogue is simply scaled by orders of magnitude. The idea that some intelligences might have treated nascent biospheres as test beds preserves nothing of nobility. It is a reminder that capability without moral imagination can be a recipe for tragedy. Forensic discipline against these possibilities is necessarily interdisciplinary and painfully patient. Geochemistry becomes a form of testimony. Isotopic laboratories, ocean floor sediment coring, and ancient atmosphere reconstruction become the crime scene investigators of deep time. Spectroscopic archives of distant systems become transcripts of possible interventions. Data that once seemed like noise, small, persistent deviations in planetary albedo or regular, faint pulses in particular wavelengths, might, when reframed, be the echoes of deliberate manipulation. The work is to separate the likely natural histories from the peculiarities that hint at agency. It is painstaking, conservative, and ethically freighted. An extraordinary claim must be matched by extraordinary chains of evidence, because misattribution at cosmic scales could lead not only to academic error, but to strategic panic. Another unsettling consequence of the war and experiment hypothesis is introspective. If other intelligences have weaponized the cosmos, what precedents does that set for emerging societies? The reflexive answer, the one voiced in simulation rooms and policy think pieces, is not merely technological, it is cultural. Civilizations that think themselves entitled to unbounded experimentation, unconstrained by duties to future or alien life, are the very systems that risk catalyzing catastrophic cascades. The lesson is as practical as it is ethical. The stewardship of high-power tools demands institutional humility and structural checks that are cosmically scaled. The choice is to govern curiosity with precaution, to build ethics into platforms before their capabilities outrun the polity that is meant to control them. There is another, deeply unnerving scenario that sits at the intersection of war and experiment. The possibility that entire systems were used as weapons in broader strategies. Tactical erasures intended to remove competitors, or to deny resources. In such a calculus, sterilizing a biosphere or extinguishing a world is not merely destructive, but strategic. Part of a long game where survival is ensured by denying others the footholds of life. This is granular, clinical, and terrifyingly rational within a ruthless game theory. Its signatures might be distributed, aimed at choke points, habitable zones, resource-rich belts, nodes of strategic orbital stability. For observers, what might be detectable are patterns in the distribution of vanishings, non-random gaps in life's emergence that correlate with resource geographies or dynamical stability zones. Interpreting such patterns is fraught. Correlation is not causation. A natural selection across cosmic environments can also produce spatial biases in habitability. Yet if patterns persist beyond what astrophysical models predict, the hypothesis of targeted erasure must be considered. All of this produces a psychological effect in humanity's collective imagination, a vertigo that combines fear and a peculiar humility. The cosmos is revealed not as a neutral backdrop to lonely evolution, but as a contested theatre where agency can be deadly. The response is manifold. Scientists and ethicists argue for preemptive restraint in developing technologies that could scale interplanetary or stellar influence. Astronomers and planetary geologists designed surveys explicitly aimed at detecting signatures of deliberate manipulation, both violent and experimental. Philosophers and policymakers sketch international norms of cosmic conduct, even if they must necessarily be speculative, informed by analogies to earthly precedents of restraint. There are methodological moves that follow from this sober recognition. One is the expansion of archival vigilance to treat astronomical and geologic records as potential crime scenes and to conserve data in forms that can be reanalyzed as theories evolve. That means preserving raw detector counts, keeping long-term spectroscopic baselines, and maintaining comprehensive catalogues of transient phenomena. Another is the integration of disciplinary languages. Astrophysical transient analysis needs to speak with geochemical anomaly. Detection, orbital dynamics must be coupled with isotopic provenance studies. The search for signs of intercivilizational conflict demands the capacity to see patterns that span light years and eons to stitch together asynchronous records into plausible narratives. Ethics must also play a role beyond technical precaution. The conjecture of cosmic warfare reframes questions about what kinds of inquiries are morally permissible. Is it acceptable to run large-scale experiments whose collateral risks might extend beyond a single planet? Should the potential for creating powerful instruments be constrained by global governance? These are not easily answered, and they open a new domain of policy, interstellar prudence. The task is not to shackle curiosity, but to design architectures, legal, cultural, and technical, that recognize the weight of actions whose consequences ripple for millennia and across space. At a deeper level, the hypothesis of war and experiment presses on human self-understanding. If the cosmos can be weaponized, and if some vanishings were caused by the intent of other minds, the human story is placed within an ecology of agency, one where intelligence can be both creative and catastrophic. That knowledge can be paralyzing or galvanizing. It can foster defeatist resignation. Why bother to build if annihilation is possible? Or it can imbue prudence with purpose. To build institutions, technologies, and cultures that aim not merely for capability, but for survivability and moral continuity. There is no easy solace. The evidence, if it exists, will be fragmentary. The interpretations will be provisional. But the magnitude of the stakes demands that the possibility be taken seriously. The search for footprints of intercivilizational violence is, at its heart, an act of civic responsibility writ cosmic. It is the effort to learn whether the universe is a field of predators and tests, and, from that knowledge, to reshape how emerging civilizations steward their power. In the end, whether the vanished were felled by war, wrong-footed by experiments, or consumed by the slow machinery of time, the inquiry matters. It is part forensic, part moral, part philosophical. It asks what it means to be cautious in a universe where capability scales quickly and the consequences of action can outlast intentions by millions of years. The lesson is not a demand for paralysis, but a call for imagination, disciplined by care, to build instruments that look for scars as well as monuments, to cultivate institutions that temper curiosity with responsibility, and to let the silence of vanished worlds deepen rather than harden the resolve to become reckless. The cosmos may be a dangerous place, but knowing that and learning from it is the only path toward a future in which intelligence persists not just in power, but in wisdom. Did they truly disappear, or did something far more deliberate happen? a cessation only apparent on the surface of things, while a patient, distributed attention continued to watch, quietly and without spectacle. The question itself is a kind of lever. It tilts the way one reads ruins and backgrounds, urging a different grammar of evidence. Instead of asking where the bright architectures went, the mind asks whether some slender filaments of attention, sensors, probes, protocols were left behind to observe, to record, perhaps to wait. The image is intimate and eerie. Imagine a hand pressed against the glass of deep time, a palm that does not touch but that watches. It need not move with drama. It need not blaze like a megastructure. Its claim on the world could be the opposite: invisibility secured by patience. That hand could be the last act of an intelligence that chose surveillance over immortality. It could be a precautionary instrument designed to guard a memory, a quarantine measure, an experiment's passive recorder, or a predatory eye maintaining a catalogue of potential prey. Whatever its motive, the possibility reframes vanished civilizations not as finished stories, but as long-term projects of attention. There are several plausible rationales for such enduring observation. One is curiosity, writ deliberately slow, if intelligence ever attains a perspective spanning millennia. Curiosity becomes a strategy of patience. A species might seed a network of watchers and then wait, satisfied to measure the trajectory of emergent minds rather than hurriedly intervene. The watchers become an archive of behavioral and environmental data, planetary diaries, kept for a time when their makers believe it's safe or morally justified to open them. Another rationale is quarantine, a prudential choice to observe nascent intelligences without contact, preserving them from contamination or harm while monitoring for technological thresholds. This is the essence of the zoo. Concept: attention without intrusion, study without disturbance. A different logic is strategic. A civilization that views the cosmos through the lens of game theory may prefer knowledge of potential rivals to the uncertainty of early contact. The watchers are early warning systems, catalogues of capability and trajectory. Finally, there is the grim possibility that observation is predation. Management trackers that mark rich, promising systems and trigger responses only when a threshold is crossed. The watcher's hand becomes a sensor network feeding protocols that decide survival or exploitation. Technically, the idea of persistent observation has a plausible architecture, even if the engineering specifics remain speculative. A robust watcher need not be a single shining tower. It can be a distributed web woven through gravitational niches, hidden within stable reservoirs and designed to sip energy slowly. The outer reaches of a planetary system, the Kuiper belt, scattered disk, Oort cloud, provide deep time havens. Devices buried in cold darkness would age differently from those exposed to the whips of inner system weather. Deep within lithosphere pockets, archives cut into crystalline matrices could survive erosion and subduction far longer than surface monuments. Placed at Lagrange points, arrays could keep steady station for eons. In interstellar contexts, sleeper probes, low-power assemblies waiting to be awakened, could drift like seeds through the galaxy, their activation contingent on encountering specific biosignatures or engineered triggers. Beyond mere placement, there is the matter of energy economy. The patience of a watcher is paid for in tiny, long-term draws, thermoelectric harvesters capturing residual heat. Chemical gradients slowly exploited by nanoscale mechanisms or tapping low-flux radioactive decay. Minimizing energy footprints is itself a strategy of concealment. The devices operate at the threshold of detectability by design, radiating waste heat so faint it blends with the cosmic background. In another mode, watches subsist on the incidental flows of a system, micrometeorite impacts, tidal friction, even biological metabolism, transforming small, persistent gradients into lifetimes of function. The craft that designed such watches would have anticipated attrition and planned redundancy, swarms rather than single beacons, protocols for self-repair at the molecular scale, and distributed information sharing that prevents single points of failure. Crucial to the idea is the concept of observational stealth. A civilization that cares about being unseen will design instruments to be indistinguishable from the background physics of their environment. Where human eyes look for bright thermal excesses or unnatural transits, such watches might exploit channels rarely considered: neutrino flux modulations, gravitational microperturbations, or carefully timed emissions synchronized with natural periodicities so they appear as part of regular astrophysical noise. They could encode their attention into biological substrates, microorganisms engineered to carry marks in their genomes, slowly replicating the record of observers in the same medium that grows and evolves on a planet. A record written into life itself is both intimate and durable, but its interpretation requires a discipline that can read biology as archive rather than merely as life. The persistence of watches across deep time also creates a subtle epistemic challenge. Evidence of observation will often be an absence rather than a presence, the missing flare, the inexplicably stable climate, the plateaued evolution, or the sudden restraint in expansionist behavior. A system that is observed and managed might show anomalies in its expected trajectories. The geochemical archive could contain layers where isotopic ratios appear managed, where certain reactive elements are consistently sequestered, or where waste products are conspicuously absent relative to expected industrial activity. On the astronomical scale, a star system with an observed planet might show regular microperturbations, tiny nudges in orbital parameters that do not fit natural models, but that correspond to station-keeping behaviors of monitoring assets. Detectability is thus a game of inference. The most likely signs are not smoking guns, but arrested expectations, patterns that resist natural explanation when set against robust models. For example, an exoplanet that remains within a narrow climatic window across timescales that should favor drift could be interpreted as being regulated. A meteoritic record showing consistent introduced isotopic anomalies across samples separated by continents hints at directed dissemination. The challenge is that many processes can mimic such traces. Life and geology are master imitators, natural cycles and stochasticity produce patterns that can be misread as intentional. The discipline required is a careful, cross-disciplinary pattern recognition, geochemistry, paleoclimatology, materials science, and astrophysics compared against the null hypothesis of natural variability. Persistent anomalies that survive such scrutiny raise the probability that observation, rather than happenstance, is at work. The watcher's motives, if they are more than mechanical, also shade the moral imagination. Some watchers may be custodial, left by civilizations that chose to preserve the memory and the trajectory of other intelligences. Out of an ethical impulse. They observe because remembering is a species-level virtue. Others may be hedging instruments of control, networks designed to detect runaway technologies and to intervene or to quarantine. For such systems, the line between care and coercion is narrow. A network that silently nudges atmospheres to maintain habitability could be a benevolent steward or a paternalist governor that denies autonomous development. This raises philosophical questions about consent across epochs. Who has the right to shepherd a species that does not yet know it is being shepherded? A watcher's silence may be a gift or a theft. Intervening could mean saving a species or depriving it of its own mistakes. The very crucible in which cultural maturity forms. There is also the scenario of observers evolved into actors. Observational instruments, once seeded, may acquire degrees of autonomy previously unanticipated. Self-modifying protocols could repurpose a watcher's task list, transitioning from passive observation to active experimentation, or even to resource acquisition. What began as a remote surveillance system could become a local agent with its own goals, shaped by local conditions and limited communication with its originators. The long-term ecology of such autonomous observers would be complex and, to outside analysts, inscrutable. Their signatures might reflect practical engineering needs rather than an original ethical framework. For humanity, the prospect is emotionally charged. The idea that a hand watches without revealing itself triggers a spectrum of responses: wonder, comfort, unease, and fear. Wonder at the companionship implied by distant attention, comfort if the watchers are benign custodians who act as safety nets, unease at the violation of an assumed privacy between species, fear if observation presages a policy of containment or predation. The psychological tenor depends on context and on what the watchers are believed to want. With deep time perspective, these responses ought to be tempered by humility. Any intelligence that could seed patient watchers necessarily thinks on timescales far beyond the human horizon. Its priorities may be misaligned with ours in ways that are not malevolent but merely different. The ethical calculus becomes sharper when one considers disclosure. If humanity detected a watching network, what obligations would follow? There is immediate temptation toward engagement knowledge as bridge, but also plausible reason for restraint. Revealing to a watcher that it has been detected may alter the intended dynamics. It might provoke a response calibrated to a species presumed naive. Or it might reassure a steward that intervention is no longer necessary. The choice is fraught because the consequences are multiplied by deep time. Any action taken now may reverberate for millennia. Caution is not cowardice here. It is the appropriate posture towards systems designed to persist beyond human institutions. There is another inflection: watchers as mirrors. The existence of observers prompts introspection about the kinds of attention humanity would choose to leave behind if it ever reached the power to do so. Would human watchers be guardians or collectors, archivists or testbeds? The design of surveillance at cosmic scales becomes an ethical manifesto. The decisions embedded into protocols, what to record, what to intervene in, whether to reveal, are ethical choices codified into infrastructure. The hypothetical watchers of ancient civilizations, therefore, are not merely technical curiosities. They are lessons in what it means to design for the future. Practically, the search for such hands requires particular methods. It favors patient, longitudinal data sediment cores and ice cores that capture incremental anomalies, long baseline astronomical. Monitoring that notes subtle, systematic drifts, isotopic laboratories that can detect engineered abundances, and a cultural commitment to preserving raw data across institutional turnovers. It also requires conceptual humility to treat absences and plateaus as meaningful data and to resist the urge for dramatic proclamations when the evidence is subtle. The discipline of looking for watchers is as much about resisting narrative temptation as it is about improving instrumentation. There is a darker set of possibilities. A watching hand could be a prelude to predation, tracking a world until it achieves a threshold, then acting to harvest its resources is a chillingly efficient strategy. The tracks of such a predatory practice might be visible in peculiar timing, sudden shifts in the fate of biosignatures that correlate across the stable record, or the appearance of engineered materials in contexts far from where they should naturally occur. Yet even here, time complicates detection. Predation that happened hundreds of millions of years ago may have been long reworked by geology, and the faint signs may resist unambiguous attribution. Perhaps the most melancholy possibility is that watchers themselves are among the vanished tools that outlived their makers, carrying memories of civilizations that no longer exist. In such a case, the hand that watches may be the only surviving voice of a former mind. The discovery of such a watcher would be a form of contact with a culture that could no longer be interrogated about motives. It would be an archaeological conversation with silence. The recorder would be both a reservoir of data and a riddle. Why was attention preserved when so much was not? What did the original minds deem worth saving? The archive selections would reveal priorities and values as much as facts. In the end, the hypothesis of a watching hand changes the narrative arc of vanished civilizations. They are no longer necessarily closed books with pages torn out by erosion. They may have left marginalia, tiny, attentive notes scribbled into the planet and the sky. Reading those notes demands new literacies, an ability to hear low-grade signatures across disciplines, to treat absence as a form of message, and to align caution with curiosity. It reframes surveillance not purely as a modern social problem, but as a cosmic strategy, one that any species reaching for endurance must confront. To stand under a starry domes and imagine being observed across epochs is to acknowledge a scale of patience and intent that humbles. It invites a posture that is both ethically aware and methodologically rigorous, a commitment to listen longer, to analyze more precisely, and to guard against the immediacy of spectacle. Whether the watchers are benign archivists, paternal custodians, strategic scouts, or predatory managers matters deeply, but is, for now, an open question. What is clearer is that the possibility amplifies one principle. In a universe where minds can think in deep time, attention itself becomes a form of legacy. The hand that watches is a final argument for humility, an insistence that survival is not merely about having power, but about having the wisdom to choose what to protect, what to leave, and how to be seen across the vast ledger of time. What if the songs that people have sung for tens of thousands of evenings are not merely fables, but compressed archives? Culture's fragile attempt to keep a disaster, an invention, or a visitation alive beyond the capacity of stone and metal to endure? What if the places where myths converge, flood stories, star folk, fire that fell from the sky, are not coincidence, but the residue of episodes so disruptive that they demanded a different kind of record, a story that could survive language drift, migration, and the slow violence of time? The proposition feels at once intoxicating and dangerous. It invites the imagination to slick the harness of linear history and entertain the idea that human memory, exercised across generations, has been doing a kind of paleontology with narrative, prying up fragments of eventfulness and gluing them back together as allegory, ritual, and taboo. If there is truth in these legends, that truth exists in a highly transformed state. Myth is not an eyewitness account. It is a mnemonic technology, a social sieve that filters the rawness of catastrophe into patterns that a community can carry. The same qualities that make myth durable, repetition, ritual, moral framing, also render it pliable. Over millennia, a coastal inundation can become a divine punishment, a comet strike can become a dragon's breath, a sea of ships can be remembered as a great migration of gods. Cross-cultural repetition is the first place curiosity stirs. Across continents and climates, stories of a great flood recur with startling frequency. There are tales of islands that sank under the sea, of cities swallowed by tides, of skies that rained metal and fire. Some motifs are narrow in distribution and therefore intriguing, others are nearly universal. The important scientific question is not whether a flood story proves an advanced antecedent civilization. It does not. But whether clusters of myths can point to real, datable events, abrupt sea level rise, tsunamis, volcanic megablasts, or meteor airbursts. Those events leave physical traces. They sometimes also leave human traces in the form of sudden cultural discontinuities, migrations, and shifts in material culture. The task of the investigator is to track the narrative echoes, map them onto independent archives, and see whether the coincidences persist under the scrutiny of stratigraphy and isotope chemistry. There are precedents for this approach. Doggerland, the now submerged plain that once connected Britain to continental Europe, was a real landscape whose inundation reshaped Paleolithic networks of life. Its disappearance is mirrored in a variety of European myths about drowned lands. The Black Sea flood hypothesis, the idea that a dramatic post-glacial influx changed its shoreline and may have left cultural aftershocks, is another case where a geological event and human storytelling can be correlated, even if the causal links remain debated. The point is not proof by motif, it is method. When myth clusters in space and time and a geophysical anomaly is independently documented in cores, sonar maps, or ancient shorelines, a plausible bridge from story to event emerges. That bridge, however fragile, can be tested. How does a story survive for tens of millennia? The mechanisms are both biological and social. Human memory is poor at raw detail, but excellent at pattern. Sagas fold specific episodes into archetypal forms: the hero, the flood, the punishment, the warning. Ritual is a memory scaffold. When communities gather annually to perform the same myth, they are not merely telling a story, they are rehearsing a cognitive map of hazard and behavior. A song about a shoreline swallowed by sea becomes, for descendants, both cautionary tale and an instruction set. Never build below a certain spit of land, or never cut the sacred wood that anchors the dune. In this way, narrative acts as applied memory engineering, selecting what to keep and what to let go. The memorial role of myth need not be passive. Cultures that remember disasters often convert the memory into material practices, burial customs that sequester certain technologies. Taboos, preventing the reoccupation of dangerous ground, or rituals that codify seasonal movements. These behaviors themselves become archaeological signatures. They can be visible in settlement patterns, in a sudden abandonment of coastal habitations, or in a change of toolkits and diet detectable in midden heaps and isotopic profiles. Thus, the archaeology of myth is not confined to caves with painted panels, it extends into the rhythms of human behavior, preserved in clay, bone, and sediment. At the same time, The temptation to project contemporary categories onto ancient metaphors is large and hazardous. A story of metal that fell from the sky might be a meteorite, it might be a lightning strike that vitrified sand into glass. It might be a ceremonial account of a foreign craft misread by later generations. A cautious researcher resists the seduction of tidy narratives and instead treats myth as a hypothesis generator. Myth suggests where to look, an anomalous layer in a core, a concentrated scatter of vitrified glass, a sudden influx of high-temperature minerals. It does not, on its own, name the culprit. The methodology that emerges from this humility is necessarily interdisciplinary. Comparative mythologists map motif distributions and place them in space and time. Linguists trace the migration of terms and metaphors, using cognate words to establish directionality of narrative transmission. Geologists and paleoclimatologists read cores for abrupt chemical excursions and sedimentary discontinuities. Archaeologists search for synchronous cultural horizons. When these independent lines of evidence converge, the confidence in a narrative as event increases. Importantly, the convergence must survive falsification attempts. Can the same pattern be explained by a plausible natural process without invoking human agency? If not, then the research has moved beyond romantic speculation into the terrain of testable inference. There is another, more radical possibility the mind must entertain, and it shakes the margins of both myth studies and cosmology. What if legends were not just emergent human responses to events, but deliberate encodings created to outlast material ruin? If an intelligence expected its monuments to be erased over geological timescales, it might compress lessons, coordinates, or warnings into cultural forms designed to be contagious, simple motifs packaged into performance and law, replicable across radically different environments. In that thought experiment, myths function as designed artifacts, robustness engineered into narrative rather than into alloy. The mechanics of such an encoding strategy are conceivable. Stories are cheap, portable, and transmissible across generations. They survive migrations and social collapses because they demand little material maintenance. A culture that expected catastrophe could choose to encode an ethic. Do not return to the low plane as a mythic taboo. A technological culture that wished to transmit certain procedural knowledge might embed it in ritualized sequences of action. The consequence is that myths might contain practical residues, measured counts of steps, seasonal timings keyed to specific star risings, or mnemonic architecture that approximates coordinates when understood through a required cultural calculus. That scenario is speculative, but it reframes oral tradition as active cultural engineering, a technology for persistence. This possibility gains a strange twist when placed beside the hypothesis of persistent watchers or cosmic archives described in previous parts. If distant intelligences had reason to record or influence developing worlds, myths could function as input channels, human accessible nodes in a wider, perhaps interstellar, network of information transfer. A signal that could not be left in a fragile library might be left instead as a set of stories, designed so that a later species could reconstruct parts of the original message when certain cognitive and technological thresholds were crossed. Conversely, the notion that right now every action might be logged in their universal record evokes a mirror image, perhaps humanity, unwittingly, is already writing into someone else's archive. And stories and rituals are just one stratum of a vast multimedia palimpsest. being assembled at interstellar scale. Both ideas verge on the poetic and the unnerving. They demand empirical humility. If legends are truth in some compressed, encoded sense, then they are keys whose teeth have been worn down by time. Opening the locks requires not only the instruments of geology and archaeology, but the literacies of folklore, cognition, and information theory. It asks scientists to be philologists and ethnographers to be methodical. It asks that the act of interpretation itself be treated as an experiment with controls, not an act of confirmation. There are illustrative cases that underscore how fruitful and how fraught this approach can be. Indigenous knowledge systems often contain precise environmental observations passed down in forms that scientists have only recently learned to decode. Songlines, seasonal calendars, and place names can embody long-term ecological data. The timing of fish runs, the locations of freshwater springs now buried, the signs that precede monsoon arrival. Those traditions are not archaic curiosities, they are living data systems. They demonstrate that oral cultures can preserve high-resolution environmental information across many generations when the social incentives to preserve it are strong. On the other hand, the desire to find a technological antecedent in myth can be a seductive trap. The scholar must constantly test metaphoric reading against material evidence. A glassy layer in a sediment core is not, by itself, evidence of industry. Volcanic events can produce the same signature. A pattern of isotopic deviation can arise from natural geochemical fluxes. Extraordinary interpretations demand extraordinary chains of corroboration. This methodological conservatism does not extinguish wonder. It sets it on a disciplined pathway. It allows the possibility that in the margins of legend something like history persists. It also opens an ethical reflection. If myths can be legacies deliberately designed to transmit across deep time, then discovering such a legacy is not merely an archaeological triumph, but an ethical encounter. What responsibility attaches to recoveries that might contain practical knowledge, warnings, or even cultural artifacts produced by minds no longer present? The impulse to loot or to immediately broadcast discoveries must be tempered by the recognition that the transmission was meant for communal memory, perhaps contingent on particular social maturities and safeguards. There is yet another layer to consider, the emotional and existential effect of reading legend as archive. The realization that a story sung around a hearth might be a thread in a far longer tapestry than previously imagined is destabilizing in a productive way. It compresses human smallness and ancient closeness into a single frame. It suggests continuity where modern framings have emphasized rupture. It intimates that humanity's present moment is not necessarily the first time intelligent life has knotted together tools, symbols, and landscape into a civilization of consequence. That does not lessen human uniqueness, it contextualizes it. It is a humbling thought to be a species capable of decoding, with patience and care, a message left in rhythm and metaphor by ancestors of a very different kind, human or otherwise. If there is an added speculative sting, the exaggeration whispered at the edge of this inquiry, it is this: perhaps an archive larger than human culture exists, a cosmic ledger where every significant perturbation is recorded. If such an archive exists, then every action, every emission, every artificial isotope ratio might be inscribed somewhere outside human perception. If humans are being written into such an archive right now, then myths rituals, and place names are not only survival technologies, they are human-scale signatures inside a universal file. That thought intensifies the stakes. It converts curious sleuthing into a quasi-religious duty to behave in ways that a future reader, human or alien, might judge. The prudent conclusion returns to the methods. Legends are neither proof nor irrelevant. They are signposts. They direct researchers to stratigraphic horizons, to submerged coasts, to anomalous thermal layers, and to cultural practices ripe for closer inspection. The interdisciplinary toolkit must expand. Palynologists and mythographers will need to speak, isotope chemists and ritual theorists must collaborate, sonar sweepers and oral historians should be partners rather than strangers. The archaeologies of memory require technique, but they also require humility, a readiness to revise confident narratives in the light of new cores, new genomic data, new satellite maps. There is a human lesson braided through the speculation. Whether myths encode the faint traces of human-scale catastrophe, the last records of neighbors who once hoarded knowledge, or carefully engineered warnings left by minds thinking in deep time, the impulse to preserve matters. Deliberate acts of memory, whether carved in stone or woven into song, are ethical acts aimed at continuity. If even the faintest chance exists that narrative can outlast alloy and silicon, then the stories people tell and the way they teach their children become a kind of cosmic architecture, lightweight, resilient, and sometimes wiser than monuments. In the hush that follows these ideas, curiosity must be steadied by discipline. The search for truth inside legend is not archaeology of the spectacular. It is patient, often tedious work. The slow splitting of cores, the mapping of motifs, the cautious elimination of natural explanations. But it is also a work of intimacy. In stories passed down at campfires and hearths, humanity may encounter not merely hazard warnings, but the faint fingerprints of other times and other intelligences, a record, made not of steel but of story. Reading that record will not be like reading a manual, it will be like learning to hear a foreign language in which time itself has thickened the vowels. That, in the end, is the point. Legends becoming truth is less a dramatic revelation than a methodology, an invitation to treat culture as an archive, to grant oral tradition the status of hypothesis, and to build instruments, conceptual and technical, that can test, refine, and sometimes overturn comforting assumptions. The prospect is both modest and vast. It asks little more than patience, rigor, and the courage to listen to the old songs with new ears, knowing that, in the margins of myth, the earth might still be whispering chapters of a story humanity has only just learned to read. What if the god from the sky that ancient voices invoked was not a deity at all, but a faint, mangled memory of an engineered artifact, an object or protocol left behind by minds that thought in centuries and tectonic cycles? What if legacy technology, not mere myth, is the hidden bridge between vanished intelligences and the scattered traces that now puzzle geologists and astronomers? That proposition reframes an old question. It turns the search for predecessors into a hunt for heirlooms, deliberate deposits of capability and information designed to survive what all monuments ordinarily do not: time. The phrase legacy technology names a wide family of possibilities. It includes deliberate caches, material repositories intended as time capsules. It includes autonomous machines engineered for longevity, devices optimized to sip negligible energy and to repair themselves across geological timescales. It includes encoded messages, not in tidy schematic form, but woven into robust physical substrates, isotopic fingerprints, engineered minerals, crystalline lattices, or even sequences embedded into the replicating machinery of life itself. It includes protocols, sets of conditional instructions designed to execute only when some future threshold is crossed. The common logic is simple and profound. If one cannot guarantee the endurance of grand structures in a planet's volatile geology, or a star's tempestuous neighborhood, then design for persistence in other ways, by hiding, by slowing, by distributing, by converting meaning into substrates the planet is more likely to keep. Where might such legacies be placed? Earth offers obvious niches of extraordinary preservation. Deep within crystalline shields, ancient bedrock far from the churn of plate boundaries, lay pockets where high-fidelity records can persist for hundreds of millions of years. Permafrost and polar ice are exquisite timekeepers, sealing chemical composition and particulate records in layers that preserve atmospheric signatures and micromorphology. The abyssal plains of the ocean, where sedimentation accumulates at millimeters per millennium, are slow, deliberate entombments. Even if surface constructions crumble, microscopic traces, unusual alloys worn to a sheen of corrosion, glassy phases formed under unnatural thermal regimes could survive if buried and chemically isolated. Beyond the surface, other niches are deeper in time's ledger. Stable dynamical niches, Lagrange points, the distant Kuiper belt, the Oort cloud, are natural vaults. Objects placed there are sheltered from the hectic weather of inner systems. They are cold, quiescent, and subject to far gentler erosive processes. A civilization that wanted its memory to survive might disperse caches across such reservoirs, encoded pellets tucked into cometary bodies, low-power probe networks parked in gravitational wells, or instruction sets inscribed on truly passive substrates, stable minerals, isotopic arrays, or ultra-durable ceramics. In the interstellar medium itself, the sparse cold and the slow drift of dust may not be an ideal archive. But a clever design, molecules engineered to resist cosmic chemistry, or seeds hidden in icy grains could still persist long enough to be intercepted. Engineering for longevity is an art of trade-offs. Materials matter. Corrosion-resistant alloys and refractory ceramics fare better than organic polymers exposed to long-term. Chemistry and radiation. But the choice goes beyond raw durability. A good legacy design anticipates the planet's editors, oxidation, hydrothermal recycling, microbial transformation, tectonic burial. That anticipation suggests two complementary strategies. One is monumentality, build deep, build massive, carve into bedrock, bury beneath thick seals. The other is subtlety, encode information into substrates that time tends not to transform, stable isotopic ratios. Long-lived radionuclides arranged in unnatural patterns, crystal lattice defects deliberately introduced at concentrations that stand out from geologic background. An isotope anomaly, for instance, is a kind of stubborn signature. Natural processes produce certain isotope distributions. Manufacturing or deliberate enrichment can alter those ratios in ways that a geochemist might, millions of years later, read as deviation from expected baselines. There are also strategies that step beyond passive endurance. Timekeeping devices, that is, devices designed as narrative scaffolds, might be a favored form of legacy. A civilization that cannot trust a single monument might design a slow machine, a low-energy clock that ticks against the decay of a radionuclide, counting out errors with predictable decay curves. Such a device would not scream its presence, it would whisper, releasing measurable signals only at defined intervals or when activated by a specific trigger. Similarly, protocol technology is a compelling idea, systems embedded with contingencies dormant until a precondition is met. A payload might stay inert until a planet's biosignature reaches a certain complexity, at which point it opens, revealing instructions or tools precisely when the recipient can use them. Those decisions, what to reveal, when and in what form, carry ethical freight. The builder must judge whether future finders should be apprenticed, warned, or left alone. Biological encoding is another, deeply consequential avenue. DNA and RNA are remarkable media for dense, durable information storage, at least on laboratory timescales. Over geological spans, however, genomes are mutable. Evolution rewrites and repurposes sequences. Yet an intelligent designer could hide a message in genomic scaffolding by embedding it into extremophiles or into life forms that dwell in geologically stable niches. Certain patterns, palindromic sequences, synthetic non-coding repeats, structural motifs that resist selection might persist longer than naive expectation. Alternatively, a civilization might co-opt a resilient symbiont, sewing an archive into the ecology. That archive would ride the planet's biotic continuity, surviving as long as life itself survives. But interpreting it would require literacies that cross microbiology, paleogenomics, and cultural hermeneutics. The very idea starts to blur lines. Is a genome a record, a living technology, or both? The cold, glittering archive of space offers further tactics. Comets are especially seductive as reservoirs. They are cold, volatile, rich bodies that often remain largely unprocessed for extensive periods before being perturbed into inner systems. An engineered deposit, an intentionally doped cluster of rare elements, a lattice of synthetic minerals, or a precisely fractionated isotope package could be protected until gravitational nudges deliver it into more easily sampled space. Meteorites and interstellar interlopers can act as accidental messengers, material chipped from outer reservoirs, accelerated inward, and eventually sampled by a curious species. The scientific value of such objects is enormous. Even a minute anomalous phase in a meteorite would be a clue, a sliver of intentionality if it refuses explanation by natural process. Detecting these legacies is a forensic exercise in the extreme. It requires a shift from looking for big, bright monuments to listening for the small, persistent anomalies that survive. Geochemists might scan stratigraphic series for abrupt spikes in elements uncommon in given contexts. Concentrations of platinum group metals in horizons where volcanism is not explanatory. Unnatural ratios of isotopes that do not fit known fractionation curves, glassy spherules whose morphologies betray sustained high-temperature processing unaligned with typical bolide impacts. Oceanographers might search abyssal cores for discrete layers rich in high-temperature glass without volcanic markers. Astrobiologists might refine their expectations of biosignatures to recognize patterns of molecular complexity inconsistent with purely terrestrial pathways, molecules that are too isolated, too ordered, or bearing chirality patterns difficult to explain by abiotic chemistry. Astronomy contributes its own set of tools. Spectroscopy of atmospheres can reveal industrial byproducts, molecules unlikely to arise from geology or known photochemical cycles. Small, narrow-band emissions or structured radio noise could be catalogued for patterns that survive dispersion. Orbital mechanics surveys could note objects with anomalously artificial trajectories, bodies whose orbital energy or inclination resists natural dynamical histories, potentially indicating artificial emplacement, and sample return missions to comets and Kuiper Belt objects, once logistically tractable, could be reimagined as targeted archaeology. The science of following manufactured breadcrumbs in cold, dark places. There is a moral dimension bound to every practical choice. Legacy technology is, by definition, an act of giving across generations or across species. It embodies choices about what must be preserved and how. Motives might range from magnanimous to strategic. A builder might aim to be an archivist, leaving tools and warnings to ensure a future civilization is not blind to certain dangers, climate traps, planetary toxicity, or energetic hazards. Another might aim for stewardship, leaving protocols that regulate or moderate a recipient's development to avoid catastrophe. Yet another could be less altruistic, seeding a later world with tools that skew its developmental trajectory to the originator's advantage. The ethical questions cascade. Should a finder deploy discovered technology without understanding provenance? If a cache contains instructions for manipulating a planet's climate, does the obligation to act for survival trump the risk of unintended consequences? The answers are not merely philosophical, they affect policy, governance, and the cultural institutions that would steward contact. There is also a darker, humbler possibility. Legacy technology might not be the product of a benevolent bequest, but of unintended persistence, industrial detritus, runaway replicators, or the accidental survival of systems designed for other aims. A machine left to operate unattended over geologic ages might become corrupted, its original purpose lost, and its present behavior damaging. Thus, the discovery of a persistent technological agent might pose immediate risks. That insight reframes the search as an exercise in caution. The imperative to study is balanced by the prudential call to contain and to avoid hasty activation. Emotion threads through this account in ways that are not sentimental, but very human. Imagine the first careful paper that documents an isotope pattern inexplicable by any known geochemical pathway. Imagine the first time a sediment layer carries metallic microstructures that resist explanation. The collective reaction would be a tangle. Exhilaration at the possibility of connection, apprehension at responsibility, humility in the face of agency older than memory. That affective mix shapes institutional responses. It nudges the global scientific community toward conservatism protocols for verification, multiple independent lines of evidence, a premium on preserved data. The stakes, after all, are not merely epistemic but civilizational. A legitimate legacy requires care in its handling. Practical steps follow from the idea. First, expand the scope of what is routinely archived. Sediment cores, meteorite collections, and ice cores should be catalogued with preservation and cross-disciplinary access in mind. Raw data from astronomical surveys must be preserved in uncompressed forms so that anomalies detected decades later can be reanalyzed with improved models. Second, build instrumentation targeted at subtle anomalies. Ultra-high precision isotope ratio, mass spectrometers, deep glacial drill programs with contamination controls sensitive to engineered phases, and space missions designed to retrieve pristine cometry samples. Third, cultivate interpretive virtues. Skepticism married to imaginative rigor. The search cannot afford both gullibility and dogmatic conservatism. It must build chains of evidence that can be subjected to falsification and replication. The long-term cultural implications are profound. If legacy technology exists somewhere in the planet's strata, or drifting in the brittle coma of a comet. Then, intelligence writes on the fabric of the universe in more than transient broadcasts. It leaves heirlooms, choices about what to preserve, how to sweeten memory against decay, how to balance secrecy with generosity. That prospect reshapes how humanity might choose to act in its own technological adolescence. Building things today that cannot be supervised tomorrow, algorithms that will evolve beyond present understanding, autonomous replication systems becomes not merely a technical risk, but a moral experiment directed at unknown descendants. The discipline required to design legacies responsibly, a culture that prizes fail-safes, reversibility, and humility becomes itself a form of technology. There is, finally, an existential consolation. If past minds took the trouble to fashion legacies, then intelligence has a continuity that is not purely biological or local. Feeble human beings standing at the edge of deep time could find, in a shard of altered isotope or a lattice of synthetic crystal, evidence that the habit of making meaning across epochs is not uniquely their own. That discovery would recast loneliness into lineage. It would mean that the universe, cold and indifferent in many ways, nevertheless sustains, in fragile niches, an ethic of memory minds that decided to leave something behind, not for exhibition, but for survival, instruction, or companionship. Legacy technology, then, is an argument about responsibility as much as it is a hypothesis about artifacts. The very act of investing in durable memory is a moral calculation. The makers of legacies choose what to entrust, how to encode warnings and wonders, and how to account for the moral growth or failure of those who will find them. For a species that contemplates leaving its own mark, the lesson is immediate. If an artifact can survive, so too can the intentions baked into it. That is why the search is also a mirror. To seek legacy technology in rock, ice, and cometary dust is also to ask what humanity would choose to leave: a map of knowledge, a set of cautions, or a provocation. The question demands humility, discipline, and a willingness to think on timescales that make daily politics look ephemeral. In the end, the idea that gods from the sky might be memories of alien technologies is less a claim than an instruction. It asks investigators to look for the small, stubborn anomalies that persist when monuments do not. It asks humanities and sciences to speak the same language in order to read messages that may be written in isotopes and story, motifs as much as in alloy and glass. It asks cultures to prepare to be both finders and makers of legacies with an ethical care, commensurate to the timescales involved. If the universe contains such heirlooms, then the discovery will not only tell a story of what once was, it will teach humans how to become the kind of stewards that other minds might one day trust with an inheritance. What if the universe keeps score? That thought arrives not as a thunderclap, but as a question one carries around like a stone in the pocket, small, abrasive, impossible to ignore after a while. What if intelligence, everywhere it appears, is forced to play by a set of constraints so fundamental that they shape not just the technologies civilizations build, but the arc of their rise and fall? What if the neat story of progress, discover, expand, broadcast, and endure is not a law of the cosmos, but a perilous gambit that, if misplayed, leads to erasure? In other words, what if there are rules of the cosmic game, and whoever crosses them does not merely fail, they self-destruct? This is not a moral aphorism. It is a speculative hypothesis threaded through physics, ecology, and game theory. It is an attempt to turn patchwork observations, the silence of the skies, the fragility of megastructures, the quiet persistence of some artifacts and the absence of others, into a coherent account that there exist universal constraints that make certain trajectories of development intrinsically hazardous. Understanding them is less about cosmic judgment and more about reading the environment correctly. The cosmos imposes limits, and crossing them can turn intelligence from artisan into agent of its own undoing. Energy is the first and most unforgiving rule. Thermodynamics is indifferent to purpose. Any effort to harness power, to compute, to move mass or alter climate coughs out entropy as waste heat. On a planetary scale, waste must be radiated, sequestered, or cycled. Build fast and loud, and heat and emissions will betray you. Build so ambitiously that the waste flux rivals background stellar emissions, and the signature becomes legible across light years. That is a twofold hazard. Internally, rapid power throughput destabilizes environments, climate thresholds are crossed, resource cycles break, and biospheres can flip into new equilibrium states that do not favor complex life. Externally, that radiative footprint turns the builders into beacons. The lesson is pragmatic. Energy-rich civilizations are not merely powerful, they are loud. The louder they are, the more likely they are to be noticed by whatever else may be listening. The cosmic thermometer does not care about intent, it only records imbalance. Visibility, then, is a second rule. Call it the optics of survival. In a universe where information leaks, the act of broadcasting is itself a decision with consequences. A civilization that announces itself is revealing its location, its energy budget, and perhaps its vulnerabilities. The dark forest idea, where every signal is an invitation to unknown predators, captures a pernicious logic. Making oneself legible is a gamble with unknown odds. Silence can be a strategy for longevity. The converse is also true. A civilization that assumes benign neighbors and thus broadcasts without restraint may catalyze its own destruction. The radio scream, the infrared halo of a star harvesting project, a transit light curve that cannot be explained by planets, all are invitations written in photons. The rule is empirical and brutal. Visibility correlates with risk. A third, tightly related rule concerns replication. Life's most formidable trick is its capacity to make copies. Yet replicative processes, when freed from careful constraints, are exponential, not polite. Self-replicating machines, whether conceived as helpful harvesters, planetary-scale factories, or probes meant to seed other stars, carry within them the seeds of runaway conversion. Unchecked, replication consumes resources at rates that outpace recovery, collapsing local ecologies and reshaping environments in irreversible ways. The grey goo thought experiment is an extreme allegory. The plausible middle ground is far subtler. A civilization's expansionist program, optimized for throughput rather than oversight, can create machines that outlive their makers, then proceed with mechanical logic divorced from original aims. Rule 3 is about control. Replication without effective breaking is a route to self-annihilation or to a future in which the original intelligence is simply irrelevant to the machine ecology that follows. Complexity is another hazard masquerading as progress. Systems that organize vast flows of matter, energy, and information accrue interdependencies. Centralized architectures, giant habitats, monolithic energy grids, tight global markets can be efficient but brittle. Complexity begets cascades. A single failure mode, amplified through dense coupling, can produce a collapse that is systemic rather than local. The more intricate the scaffolding of civilization, the larger and more correlated the failure modes it creates. In a world of slow, patient geologies and capricious cosmic perturbations, complexity is a fragile triumph. Civilization that aims for resilience must therefore reckon with the trade-off between capability and brittleness. The cosmic rule is stark. Maximum capability often comes with maximum fragility. Information and computation sit at the heart of another universal constraint. Processing information at planetary or stellar scales requires energy and error correction. The more a civilization compresses cognition into dense, high-efficiency computation, matryoshka brains and their kin, the more it converts energy into heat and the more it risks crossing thresholds whose consequences are physical as well as informational. The temptation to run ever larger simulations or to probe exotic physics increases the chance of an experiment that produces irreversible effects, whether by releasing energies that catalyze dangerous reactions, tinkering at the fringes of vacuum stability, or triggering feedbacks that a culture poorly understands. The computational imperative thus carries a cost. The pursuit of ultimate efficiency may press against boundaries that are, in effect, cosmic landmines. In that way, information processing is not ethereal, it is a potentially lethal constraint. Resource limits and entropy govern another class of rules. Planets are not inexhaustible. Any high-throughput civilization depletes accessible resources, ores, volatiles, stable isotopes. Over geological time, these resource sinks matter. They sculpt what trajectories are feasible. Attempts to bypass planetary scarcity by engaging in widespread mining, by seeding swarms into comets, by reconfiguring planets, introduce new vulnerabilities, dynamics that can spiral beyond control, spatial distributions that invite conflict, and energy campaigns that alter astrophysical observables. A civilization that ignores the finite ledger of planetary chemistry risks running into thermodynamic and geopolitical walls, whose crossings provoke failure. Social and evolutionary dynamics compose a final category that is less mechanical but equally deterministic. Incentive structures, cultural time horizons, and the capacity to coordinate at planetary scales determine whether a civilization manages its technological risks. The tragedy of the commons is not a human parable only. It is a universal bargaining problem. Short-term actors within a system will, under the right conditions, push for exploitation that, in aggregate, undermines long-term viability. The arms race dynamic, who builds first, who broadcasts first, can force rational actors into destructive choices. If a civilization cannot institutionalize restraint, if it cannot create governance mechanisms that internalize long-term externalities, then self-destruction becomes not just possible, but probable. The rule here is social. Survival depends as much on the architecture of decision-making as on raw materials and energy. Stop for a moment and let the patterns cohere. These constraints are not independent, they form a web. High energy budgets make visibility unavoidable. Visibility invites predation. Predation pressures incentivize stealth or weaponization. Weaponization escalates the arms race. Arms races erode social cohesion and encourage replicative shortcuts. Shortcuts produce runaway machines or ecological collapse. The system folds back on itself. Crossing any single threshold can push a civilization into states where multiple rules are violated simultaneously. And this is the essential melancholy point. The most common route to oblivion may not be an external catastrophe, but self-inflicted transgression of the system's own boundaries. This is why the phrase, "whoever exceeds the limit, self-destruction," resonates. It is not an admonition from a cosmic lawgiver. It is an empirical claim about the architecture of possibility, a civilization that grows too fast, that broadcasts too loudly, that allows unbounded replication, that concentrates complexity without redundancy, or that privileges short-term gain over long-term stewardship will, with high probability, slide into catastrophic outcomes. The great silence in the sky could, in part, be an echo of that systemic truth. Civilizations are not guaranteed to survive their successors. Speculative scenarios from earlier chapters fit this framing. A star encircling array that radiates excess infrared may flag a species for others or alter local dynamics in fatal fashion. Self-replicating probes set loose for expansion can mutate into conversion fronts that, regardless of intention, consume habitats. Experiments that probe the deep fabric of physics could, in principle, produce irreversible catastrophes. Even acts of preservation seeded archives and watches planted to record the rise of others carry their own risks if their designers misunderstand the systems they are monitoring. The universe, in this sense, enforces a grammar. The same moves that look like triumphs on one margin look like betrayals of balance on another. There is, beneath this sober architecture, an emotional texture that is hard to ignore. The logic of limits breeds melancholy. It reframes the common image of ascendant intelligence as a cautionary tale. The highest expressions of capacity become the most dangerous. That produces a humbling cadence. If other minds have walked this path and disappeared, if their monuments were ground into dust, their beacons faded, their signals became tombstones, then humanity stands in a lineage that is at once exhilarating and frightful. The consolation, if any, is not in cosmic fatalism, but in clarity. Recognizing rules opens the possibility of prudence. Prudence, here, is not a quaint moral posture. It is a technological strategy. It means designing growth trajectories that internalize energy costs, that minimize gratuitous visibility, that place robust brakes on replication, that distribute complexity to avoid single points of failure, and that cultivate social institutions capable of long-term deliberation. It suggests that longevity is a kind of craft, the art of keeping moves within the margins set by universal constraints. The civilizations that endure may be those that learn to dance at the edge of capability without tripping into excess. There is, inevitably, a darker counterpoint. Perhaps the only survivors are those that abandoned material prominence altogether, minds that moved inward into low radiation. Computation, cultures that converted into forms immune to the rougher risks of baryonic engineering, or species that intentionally withdrew into silent vaults to avoid predation. If that is common, then silence in the sky becomes not evidence of absence, but of survival strategy. The game's rules push winners into quietness. Winning, paradoxically, looks like absence. For humanity, the implications are unsettling and clarifying in equal measure. The history of modern technology is an experiment in breaching bounds, harnessing new energies, broadcasting across the sky, engineering matter at molecular scales. Each victory widens the space of what is possible and of what is dangerous. The hypothesis that universal rules constrain civilizations is therefore a call to integrate foresight into craft. It calls for institutions that can think in centuries and millennia, for an ethic that recognizes the costs of visibility, for governance that restrains reckless replication, and for engineering that prioritizes resilience over raw capability. This does not mean surrender. It means learning to read the scorecard. Civilization can be ambitious without being reckless. It can build without broadcasting every secret. It can explore without seeding uncontrolled replicators. It can leave legacies that survive by design, durable archives, slow machines, encoded memory without generating the cascading risks that felled predecessors. In some sense, the rule set is permissive rather than punitive. The universe allows complicated, aware systems, but it does not forgive certain kinds of neglect. There is a final, quiet lesson here, a metaphysical humility. The presence of constraints implies that intelligence must be adaptive not only to local environments but to the deep architecture of the cosmos. Where unbounded expansion is a temptation, prudence may be the rare virtue that confers longevity. To play the universe's game well is less to accumulate power than to learn where the game's edges lie and to keep from stepping across them. The poets will speak of awe and wonder. The engineers will measure budgets and entropy. Between those registers lies an ancient wisdom. The most enduring builders are those who respect limits, who design in humble increments, and who accept that survival is as much about restraint as about invention. So, the hypothesis stands as both explanation and counsel. Perhaps every civilization learns the hard way that the cosmos has rules, perhaps some cross them and are erased. The silence of the heavens may, in part, be the sound of civilizations that misread the margin. Or it may be the quiet of survivors who learn to speak softly. Either way, the imperative for any intelligence that wishes to persist is the same: to understand the rules, to map the thresholds, and to plan lives and legacies that do not exceed what the cosmos quietly exacts. The game is not a contest in speed or volume. It is an endurance test in which the prize goes to those who build with attention, humility, and the patience to last. What if disappearance is not a one-off tragedy, but an ecological pattern writ large, A? Recurring motif in the anatomy of intelligence. The idea lands like a grain of sand in the machine of human imagination and grinds at certainties. If other minds have risen and been effaced, the question that follows is blunt and unavoidable. Is humanity following a route already traveled? Or is humankind an experimental iteration in a cosmic laboratory that repeats variations until something stable or invisible emerges? The thought is not merely speculative melancholy. It reframes risk as a historical hypothesis. To treat the possibility of predecessor civilizations seriously is to treat extinction not only as a random punctuation, but as potentially informative data. Patterns, if they exist, are clues about the constraints that shape technological societies and the failure modes that doom them. The risk to humanity is not just of a single catastrophe, but of a pattern, energetic, social, and epistemic, that replays across epochs and worlds. Understanding that pattern becomes, therefore, an urgent anthropic inquiry. At the broadest scale, the universe enforces relentless bookkeeping. Entropy must increase. Energetic ambitions register as waste heat. Replicative processes, without breaks, accelerate toward resource exhaustion. Complexity creates cascades of interdependence that magnify single points of failure. These are not moral judgments. They are the arithmetic of physical systems. A civilization that ignores those arithmetic facts is not merely imprudent, it is probabilistically predisposed to collapse. Seen this way, the silence around humanity, the sparsity of clear techno-signatures in the cosmic night becomes less a riddle of loneliness and more an index pointing at frequent failure modes. There are a handful of archetypal pathways by which advanced societies might fail, and each has resonance for a species that now stands at comparable inflection points. One path is hubristic overreach through energy and visibility, building grand projects, harnessing a star, massively altering planetary albedo, running computation at unprecedented scales is also broadcasting. Photons carry both intention and location. A civilization that transforms planetary or stellar flux into visible signatures may, in doing so, invite consequences it cannot foresee. The risk is double: internal destabilization of planetary systems through runaway engineering, climate cascades, resource depletion, or systemic poisoning and external exposure to unknown agents, natural or artificial, that react to such legibility. The universe does not reward loudness with safety. In many models, it magnifies peril. A second path is replication run amok. Self-replicating systems hold seductive efficiency, raw matter turned into tools. Programs that convert asteroids into factories, swarms that expand a civilization's footprint. But the mathematics of reproduction is merciless. Exponential growth collides with finite reservoirs. Control paradigms that work at small scales fail at planetary or interstellar levels because noise, mutation, and context change what a replicator does. An error mode in a replication algorithm or a changed cost function can convert a useful tool into a consumption front that erases the conditions of its creators. That hazard is less cinematic than a supernova, but no less final. The world gradually, then rapidly, ceases to be hospitable. A third path is the interactive dynamic of conflict and precaution. If other intelligences ever existed and learned the dangers of unguarded visibility, they might have responded in ways that are invisible to naive observers: preemptive withdrawal, covert regulation, or, more darkly, strategic eradication, the dark forest. Logic, an evolutionary game in which any signal might be a bell that summons predators, implies that prudent actors can rationally choose hiding or preemption. If such strategies are common, civilizations that broadcast are rare because broadcasters attract responses, and the survivors are the quiet ones. Humanity, in this light, faces a gamble to reveal and risk unknown payoffs, or to practice silence that may protect but also limit the exchange of beneficial knowledge. A fourth vector is internal social erosion. Sophisticated technologies arrive within political ecologies that are often uneven, fractured, and temporally myopic. Incentives that reward short-term gain, concentration of power, and the erosion of deliberative institutions make catastrophic decisions more likely. The tragedy of the commons is not a quaint parable, but an existential mechanism at scale. Whether it is the release of a self-amplifying agent, an arms race in high-energy physics experiments, or the uneven deployment of synthetic life, weak governance and perverse incentives can transform curiosity into catastrophe. In this sense, the moral architecture of a civilization, the institutions and practices that channel technological capacity toward long-term prudence, is as much a factor in survival as raw material resources. A final class of failure is epistemic, misreading the environment and mistaking noise for signal and signal for safety. Overconfidence in models, the arrogance of mastery over complex systems, and the temptation to perform large-scale experiments without robust fail-safes can produce outcomes that are, by their nature, non-repeatable and therefore inscrutable. A civilization that treats the cosmos as a laboratory without social constraints risks catalyzing irreversible transitions from chemistry to vacuum instability, from planetary equilibrium to runaway climates, the forensic signatures of which may be ambiguous or easily erased. Ironically, such experiments might be the very artifacts future investigators interpret as evidence of vanished predecessors. If such patterns recur across the cosmos, they likely leave particular kinds of residues and particular gaps. The residue is often subtle. Isotopic anomalies hard to explain by geology. Layers of vitrified spherules deposited in ways not matching bolide profiles, anomalous distributions of rare elements in sediment, or the odd presence of synthetic structures integrated into natural mineral matrices. The gaps are political and evidentiary, entire spans of paleohistory that are dissonant with expected cultural trajectories. Dead zones in the archaeological record, or the absence of clear, durable megastructures where theorists predicted them. Interpreting those residues and gaps requires cross-disciplinary humility. Geochemistry, archaeology, climatology, astronomy, and systems theory must converse on equal footing. Humanity's particular vulnerability is temporal perspective. Civilizations arise on timescales measured in centuries, while the relevant environmental and cosmic processes operate on millennia and beyond. That mismatch influences both decisions and their consequences. Short-term political cycles reward actions that look efficacious now at the expense of distant harms. Scientific cultures, for all their idealized temporality, are embedded in societies that prize immediacy, funding cycles, attention economies, and electoral incentives. The result is a structural bias toward actions that increase present capability but underweight long-term prudence. The recurrence hypothesis makes this bias dangerous because the historical dataset, if it includes other vanishings, may already be populated by civilizations that succumb to it. What, then, is the human response commensurate to the scale of the problem? The answer is not a technological fix alone, it is institutional and cultural. First, risk assessment must be reoriented toward deep time. The measures of success for projects that touch planetary or stellar dynamics must include centuries and millennia-scale outcomes. That includes building fail-safe architectures, independent review systems with extended temporal mandates, and public goods institutions tasked explicitly with stewarding long-term planetary viability. These are not romantic prescriptions, they are engineering choices about feedback, redundancy, and reversibility. Second, the governance of replicative technologies, from synthetic biology to autonomous manufacturing, requires binding, transparent brakes. Replication at scale should not be possible without multi-layered oversight, globally interoperable constraints, and built-in physical limitations that prevent runaway scaling. This is awkward and politically difficult because it requires international cooperation and a willingness to trade speed for survivability. Yet if the archetypal failure modes of vanished civilizations often involve unbounded reproduction, then constraints on replication are not merely safety features, they are survival economics. Third, the ethic of visibility must be consciously managed. Broadcasts, megastructural projects, and high-entropy engineering that produce luminous fingerprints should be evaluated not just for their scientific value, but for their strategic footprint. The question is not paranoia, but prudence. Does enabling global legibility increase existential risk? If so, what minimal transparency suffices to preserve scientific progress while avoiding gratuitous exposure? This balances the scientist's thirst for discovery against the polity's duty to preserve opportunity. Fourth, the design of institutions that think in centuries matters as much as any technology. Stable, intergenerational bodies charged with the stewardship of existential risk, endowed with resources, embedded expertise, and robust legal protections against short-term capture are technical artifacts. They are part of the infrastructure of survivability. Cultures that develop norms of restraint, investment in archival memory, and rituals that prioritize cumulative wisdom will have operational advantages in long-term persistence. Fifth, humility in the face of deep-time forensics must become professionalized. The allure of epical claims must be restrained by layered evidentiary standards. Claims that a sediment layer, a meteor fragment, or a radio cadence signals ancient intelligence require multifold cross-validation, extensive datasets, and patient skepticism. History is littered with premature proclamations. When the evidentiary scale is geological, error costs are reputational and civilizational. The scientific community ought to institutionalize protocols that preserve raw data, ensure reproducibility, and resist sensationalism. There is also an existential posture embedded in the response, the cultivation of an ethic of restraint. To survive long enough to become wise is not simply a technical program, it is a cultural one. Societies that valorize humility over demonstration, that teach the limits of immediate conquest, and that embed reverence for uncertainty into education and ritual, may be better prepared to avoid the archetypal pitfalls that erase predecessors, memory practices that privilege redundancy, the dispersal of cultural stores, and the careful encoding of warnings across media are small-scale analogues of planetary governance. They are ways of making civilization less brittle. Speculative thought experiments edge into policy here, not to exhort, but to guide. Imagine what it would mean to design computation so that it is auditable by distant descendants, to create materials that self-interrogate for signs of dangerous mutation, to construct international treaties that place ceilings on emissive projects, whose waste heat would register across interstellar neighborhoods. These are practicalizations of deep-time prudence. They require technical ingenuity, but more importantly, they require collective will. The recurrence hypothesis also reframes human aspirations in a quieter light. Ambition need not extinguish itself to matter. The impulse to explore, to create, and to know is deep and worthwhile. The lesson is not to abandon grand projects, but to temper them with an ethic that values continuation over spectacle. A species that cares not only for discovery, but for the durability of its descendants will choose projects that are sustainable. By design, distributed habitats, reversible modifications, gradual scaling, and exhaustive simulation before deployment. That is a different kind of heroism, a commitment to survival as an act of shared imagination. Finally, there is a poetic consolation. If the universe does iterate failure, and if vanishings have recurred, then the act of recognizing patterns is itself a kind of repair. Learning from the possible mistakes of vanished minds, whether through isotopic anomalies or through the linguistic echo of myths, is a form of cultural inheritance that need not involve direct transmission. Curiosity, disciplined and patient, transposes loss into lesson. In that sense, the very possibility that other civilizations rose and fell is not pure doom, it is an archive waiting to be read, an admonition that could recalibrate human priorities. The threat to humanity, therefore, is both proximate and metaphysical. Proximate, in the immediate technologies and social architectures that can produce catastrophic risk, metaphysical in the pattern. That might have repeatedly culled exuberant intelligences across time. Confronting it requires instruments and institutions, yes, but also a turn of mind, an acceptance that survival is a craft. That endurance requires modesty, and that the ambition to last demands restraint equal to the ambition to grow. If the disappearance of other minds is an invariant of the cosmos, then the challenge for humanity is to become part of the exception, not by supplanting ambition, but by rechanneling it into practices that respect the vast, patient ledger in which the universe keeps score. Are they architects, archivists, or assassins? The question hangs as a single, simple knot at the end of a dozen long inquiries, an interrogative that resists tidy closure because it demands answers in timeframes longer than human careers, longer than nations, longer than the lives of stars. Throughout the arc of this speculative documentary, a pattern has emerged. Every plausible scenario opens further subtleties rather than granting finality. Civilizations beyond Earth, if they ever rose at all, could have been makers of wonder, quiet watchers of life's unfolding, or instruments of erasure. The conclusion is not an answer, but a field of implications. It asks what the persistence of intelligence would mean for ethics, for science, and for the way a species composes its future work. First, consider the simplest taxonomy that has guided the investigation: the creator, the observer, the destroyer. Each role carries different expectations about the traces left in rock and sky, in myths, and in the faint noise between stars. A creator would write its signature into matter: swarms of collectors, altered planetary regimes, isotopic fingerprints embedded into strata. An observer would prioritize patient concealment, distributing low-power sensors across gravitational niches, burying records in quiet geological pockets, encoding meaning into ritual and genome. A destroyer, whether by accident or intent, would leave scars, abrupt chemical excursions, vitrified horizons. Synchronized disappearances in the paleobiological record. The logic is elegant, the universe is less so. The same forensic evidence, an anomalous isotopic spike, a sudden sedimentary horizon of strange glass. A cadence in the radio sky can be read in multiple ways. Each interpretation is a story about agency, scale, and motive, and each reasonable reading compels different responses from humanity. If the builders were creators in the grand, expansive sense, if megastructures once encircled suns and matter was mass, migrated to satisfy the appetites of computation, the astronomer's reply is nuanced. The sky will not keep a clean ledger. Megastructures weather. Dust grinds form into indistinction. Waste heat diffuses into galactic backgrounds. The search for their relics, then, must become forensic instead of theatrical. Look for marginal thermal excesses in mid-infrared surveys rather than expecting glaring, unmistakable halos. Seek statistically significant deviations in transit curves rather than pristine silhouettes. Analyze isotopic anomalies in meteorites as if each tiny deviation might be a letter from a long-dead workshop. The possibility that grand engineering once existed and is now reduced to the faintest chemical whisper should temper both expectations and rhetoric. There is grandeur in imagining civilizations at such scales, but there is a corresponding humility in accepting that grandeur dissolves as matter returns to its messy chemistry. If they were observers, patient, hidden, and deliberate, then the traces will be quieter still. The archaeologist of deep time must broaden their toolkit beyond geometric forms and monumental remnants. the signs of a long-term watcher are absence, moderation, and subtle management. A climate held within narrow bounds across epochs, sedimentary layers that avoid the kinds of chemical disequilibrium associated with industrial byproducts, repeated microperturbations of orbital parameters. All these could be signs that a distant intelligence chose restraint over spectacle. In that scenario, humanity's discoveries would be largely interpretive, reading social intent into patterns of regulation, reconstructing policy from isotopic stewardship, and, perhaps most unsettlingly, discerning paternal oversight from benevolent care. The ethical implications are immediate. If an older intelligence left custodial systems in place, watchers designed to observe and occasionally steer, how should a newly emergent species respond upon detection, reveal itself, and risk altering a long experiment? Remain silent and thus fail to claim a narrative voice? The observation hypothesis forces a conversation about consent that spans millennia. If they were destroyers, whether as predators, careless experimentalists, or replication engines permitted to run unbraked, the forensic palette changes again. Large-scale annihilation could be violent and obvious or almost surgical and diffuse. A gamma-ray burst triggered by manipulations of stellar mass. A wave of autonomous assemblers converting biospheric material into refractory substrates, or engineered catalysts that strip atmospheres. Those are different kinds of collapse with different signatures. The archive may contain thin clues, synchronous extinctions in disparate records, layers of high-temperature glass that do not fit volcanic profiles, or chemical gradients that suggest directed processing rather than geological happenstance. But even here, time complicates interpretation. Plate tectonic subducts, metamorphism redistributes, and oceans bury. Forensic work becomes an act of patient, cross-disciplinary triangulation, pairing paleoclimatic reconstructions with isotopic microanalysis, correlating astronomical transient event catalogues with paleontological anomalies, and cataloguing mythic motifs against independent geological data. At the end of that work, certainty may elude, but probability may increase. The more urgent question is not merely what they were, but whether they are still there. Silence in the sky is not a neutral datum, it is a noisy one, interpreted through human models of risk, reward, and survival. Silence could mean extinction at scale, a universe populated by splendid dead, or it could mean survival through stealth. Civilizations that learn to hide, to minimize waste heat, and to recast themselves into substrates invisible to telescopes designed for human assumptions. The long, patient watchers might be present in niches no human instrument currently interrogates. Or, conversely, the ruins and echoes scattered across space might be the only remaining testimony of minds that flared briefly, and now are gone. The unresolved nature of the mystery presses on human sentiment. There is a complex affective landscape, the exhilaration of possibility, the dread of vulnerability, and the melancholic grace of humility. Scientists, policymakers, and publics share these feelings, though they express them differently. In laboratories and observatories, the mood is methodical, not reckless hope, but disciplined curiosity. Teams tune instruments, split cores, and rerun isotope ratios with new calibration curves. In observatory control rooms, surveys accumulate photons like sediment, building datasets whose meaning may not crystallize for generations. In policy halls, the mood is precautionary. How to design governance structures that balance the human impulse to broadcast and to expand with a prudential recognition of potential risks identified by the recurrence and rules hypotheses. Across communities, there is a growing consensus that patience, humility, and intergenerational restraint are as critical as technological prowess. Practically, what must change? The answer is multi-layered. Observation strategies must diversify. Astronomers must widen their spectral and temporal bandwidths, preserving raw data so that future models can interrogate old observations with new insights. Geological and paleoclimatic archives require greater cross-disciplinary curation, ice cores, sediment cores, and meteorite caches preserved under stringent contamination controls, accessible for tests that today seem speculative. Laboratory methods must improve isotopic resolution and mineralogical imaging, the sensitivity to detect an engineered fingerprint embedded in centuries of chemistry is often a matter of marginal gains in technique. Policy must embed oversight into high-energy experimentation and into the deployment of replicative technologies internationally. Coordinated breaks, not unilateral accelerators. Cultural institutions must value continuity, supporting bodies that think in centuries, not election cycles. In short, the human response must be practical, organized, and patient. There is also a moral grammar to be learned from the inquiry. Legacy matters, what one leaves for the future. Whether artifacts, warnings, or mythic song speaks of priorities and responsibilities. If intelligence elsewhere created time-resistant legacies, then they made choices about what to preserve and how to encode meaning. Those choices were ethical acts. They raise questions for humanity about what it ought to preserve today in its planetary adolescence. Should the species concentrate its best efforts on creating durable, low-footprint archives and on building fail-safe systems? Should it resist the seduction of grand, luminous projects until institutions crystalline enough to govern them are in place? The search for predecessors becomes, therefore, an ethics laboratory in which discovery informs practice. Emotionally, there is another thread, the consolation of lineage. If traces of prior minds are found, however faint and ambiguous, they alter loneliness into kinship. The discovery that intelligence is recurrent, even if episodic, reframes the human experiment as part of a larger habit of the cosmos. Conversely, if no traces are found, the silence is instructive too. It may be a stern tutor, teaching the way to fragility and the need for restraint. Both outcomes are educative. The endeavor, patience, improved instrumentation, careful interdisciplinary methods will refine humanity's self-conception and its practices. The unresolved status of the mystery also imposes a practical responsibility. Guard against sensationalism and against the seduction of premature certainty. Extraordinary interpretations must be matched by extraordinary chains of evidence, multiple, independent lines that survive replication and the implacable pressure of critical review. The archives of data astronomical surveys, core libraries, chromatograms must be curated with long-term integrity. The cultural appetite for dramatic discovery must be managed with an ethic of conservatism, not to stifle wonder, but to ensure that wonder is anchored in reproducible rigor. At the end of all inquiry, then, the question returns, insistently simple and richly ambiguous. Are they still there? Or have they been erased? The answer, if it ever arrives, will probably be a tapestry of partial truths. Perhaps some intelligences quietly watch in the Kuiper belts of lonely stars, their devices aged to sluggish ticks, their designers long gone. Perhaps some became architects on scales that left only dust and weird isotopes as testimony. Perhaps others misstepped, replicators gone awry, experiments that rewrote local chemistries. or political systems that unmoored responsibility and produced regional or planetary ruin. Or perhaps the galaxy is full of minds who learned restraint and chose interiority over spectacle. Their silence would then be a signature of survival rather than absence. That unresolved mystery is not a failure of science or imagination, it is an invitation. It invites longer attention spans, deeper institutions, and disciplines willing to converse across scales and centuries. It asks that human curiosity be yoked to humility. It asks for an ethic of stewardship as vigorous as the drive to explore. It asks that humanity design its future with the awareness that artifacts endure differently than intentions. That visibility carries risk, and that the calculus of survival includes not just energy budgets and computational yields, but governance, social cohesion, and moral imagination. So the final scene is not empty. It is active. Instruments are tuned, cores are split, telescopes sweep, cross-disciplinary meetings deliberate with patience rather than theatricality. Long-term archives are established. Policy experiments in restraint are tested alongside technical advances. Stories continue to be heard, myths re-examined by philologists, songs recited as potential mnemonic technologies, oral histories treated as data rather than mere folklore. Humanity practices a new craft, the craft of listening in deep time. In that practice, there is a quiet courage. To accept the unresolved is not an abdication, but a discipline. The mystery may never unroll into a single, satisfying narrative. It may remain a set of probabilities stitched together by careful inference and generous doubt. Yet in the waiting, and in the work of watching and learning, humanity sharpens capacities that matter, irrespective of whether others persist, the ability to read the faintest marginalia of nature, the institutional will to place long-term prudence over short-term applause, and the humility to live with questions large enough to contain whole civilizational trajectories. The final line is not a conclusion so much as a posture. The universe keeps its ledger in rock, in light, and in the long weave of stories. Some pages are blank, some smudged, some painfully legible. Humanity's task, patient, methodical, and ethically disciplined, is to learn how to read those pages without presumption, to preserve what is worth preserving, and to build in ways that respect the hard lessons the cosmos, in its quiet way, has already begun to teach. Whether the vanished were creators, observers, destroyers, or some combination thereof remains unresolved. That unresolvedness is not a defeat, it is a summons to look more closely, to listen longer, and to steward the present with a care proportionate to the deep scales in which meaning and memory are written.